You are lying beneath an invisible ceiling, the dome of night. The stars do not shout, they breathe light into darkness. Somewhere out there, beyond the circle of familiar planets, a faint body begins its approach. It is no spacecraft, no signal, no fragment of a broken world. It is a traveler, an interstellar object, wandering into the warmth of our sun after uncountable ages adrift between stars. You do not see it with your eyes, but you sense it, as though a whisper in the quiet air has brushed your thoughts. The traveler has a name now, 3i Atlas, given by those who found it with cold mirrors of glass and light. But it had existed long before names. Long before human eyes learned to look upward and wonder, this small frozen body journeyed through the dark ocean between stars, untouched and unobserved. It carries the story of another sun, another cradle of worlds, another beginning. Its orbit tells astronomers that it came from outside, moving too fast to be bound by our sun's gravity. You imagine it gliding in, crossing the invisible frontier where the solar system thins into interstellar space. The idea of it feels ancient. A piece of another planetary nursery, flung away when its own system was young. Perhaps a collision tossed it out, or the chaotic pull of giant planets gave it a final shove toward the abyss. It wandered through the galactic night, alone for millions, maybe billions, of years. No warmth, no light, no sound. Only the slow drift through cosmic stillness, wrapped in its frozen shell. When you think of that time, you feel the scale of patience the universe requires, a patience so vast it silences your thoughts. Now, after an eternity of solitude, the traveler meets our sun. The faint gravity of our star bends its path, not enough to capture it, only to invite it closer. You picture it like a snowflake falling past a candle flame, brushing the heat, then carrying onward into the night. Its nucleus is small, perhaps a few kilometers wide, yet within it lies matter unchanged since the dawn of its birth. Ice, dust, silicates, carbon compounds, preserved like an untouched library of another world's history. You imagine astronomers watching their screens, seeing a tiny streak of light move against the black background of stars. They measure, calculate, trace the curve of its motion. Each coordinate becomes a syllable in the poem of its arrival. You are there with them in spirit, holding your breath, feeling the quiet excitement of discovery that always carries a note of reverence. Because this visitor is not merely a rock. It is a message, written not in words, but in its existence. A reminder that our solar system is not alone, not sealed away, but open to the wandering company of others. When you close your eyes, you picture the solar system as a gentle field of gravity and light, the sun at the center, planets circling like notes around a long, slow melody. Into this music, 3i Atlas drifts, carrying a harmony that belongs to another song entirely. For a brief moment, both melodies overlap, the one we know, and the one from far away. In that overlap, something beautiful happens. The realization that the universe is not a collection of separate songs, but a single symphony of motion. You take a slow breath. You think of how many stories have crossed paths with yours, how many unknown travelers have brushed your life unnoticed. The comet becomes a metaphor for connection, the way something foreign can enter a system and, by its mere passing, change how that system understands itself. Our astronomers are doing the same now, rethinking what defines a solar system, what belongs, and what visits. The arrival of 3i Atlas is not a disruption, but an expansion of meaning. It is easy to imagine loneliness in the vastness of space. But this visitor, silent and ancient, tells you something else, that even across incomprehensible distances, paths can cross. In its quiet trajectory, you see a reflection of your own movement through life, sometimes solitary, sometimes seen, always part of something larger. The comet does not aim for discovery, it simply travels. And yet, by doing so, it becomes a revelation. The sun's light will soon touch it. Even now, as it approaches, the outer layers begin to warm. Molecules of frozen gas tremble, preparing to sublimate, to leap from solid to vapor, from silence to shimmer. A tail may soon form, faint and graceful, tracing the invisible forces that guide it. But that will come later. For now, it remains quiet, a distant glow against a canvas of stars. You breathe again, letting your thoughts settle. The comet's journey becomes your meditation, the long fall inward, the soft encounter with warmth, the inevitable drift outward again. You realize that this rhythm, approach, encounter, departure, belongs not only to celestial objects, but to every life, every experience. Everything that enters your orbit leaves a trace, however faint. For tonight, you let yourself rest in that awareness. The traveler is still far away, moving through the borderlands where sunlight grows thin. Yet already, its whisper changes how you see the night sky. You look upward and feel that subtle difference, a touch of foreign light among the familiar constellations. The heavens have grown slightly wider, slightly deeper, slightly more alive. Somewhere in that widening, you sense peace. You feel the slow pulse of the universe, the expansion and return, the endless exchange of energy and story. The visitor does not disturb that balance. It reveals it. Its motion is proof that even in deep space, there are connections unseen, quiet bridges between worlds. You let that thought linger, soft as breath. The traveler continues its slow arc inward, unseen but deeply present. Soon, sunlight will reach its surface. Soon, the silence will begin to transform. And as you drift closer to sleep, you wonder, what hidden tales lie frozen inside this ancient ice, waiting for the first touch of warmth to awaken them? You imagine it now, the path through the dark, older than memory. A single fragment of rock and ice, once circling a distant star, sent spinning outward by the invisible hands of gravity. You picture it leaving its home system long before our Earth had even formed. The ejection was not violent, not loud. It was an elegant push from the dance of young planets, the way a child might skip a stone across a pond. One strong motion, and the traveler was free, slipping into the interstellar ocean. In that ocean, there is no up or down, no map, no return. The space between stars is almost nothing and almost everything, so thin that you could cross 1,000 kilometers before meeting a single atom of gas, and yet so full that it carries the magnetic hum of galaxies. Through this invisible sea, the traveler drifted, turning slowly in its sleep. It felt no warmth, no gravity strong enough to guide it. Just the endless pull of inertia, carrying it forward like a leaf caught in an infinite wind. You let yourself feel that motion. The deep quiet, the steady glide, the long patience of a body with nowhere to go and eternity to get there. Out there, time stretches differently. Without a sun to orbit, without the changing seasons of light, time loses its rhythm. Each year, each million years, becomes the same, a slow, unbroken now. Perhaps the traveler passed other stars along the way. Each one a brief flicker of warmth, a passing light in the endless dark. Gravity tugged gently at it, offering a choice to turn, to fall, to stay, but none strong enough. It continued onward, slipping past those invitations, following a path no mind could predict. The galaxy moved around it, stars shifting their places, spiral arms rotating like the petals of a flower. The traveler kept moving. Always onward. Always elsewhere. You wonder what it means for something to belong to nowhere. Every planet, every moon you know has a home, a center it orbits, a parent star that gives it purpose. But this object, this interstellar wanderer, has no such tether. It exists between homes, between systems, between stories. And yet, it still exists. It still endures. In that realization, you feel something soften inside you, the quiet comfort that even without belonging, there is still being. The journey from elsewhere carries secrets. The dust upon its surface may have condensed in a region where sunlight was weaker, where ices formed differently, where chemistry took another shape. Its elements might tell of a star slightly redder or bluer than our Sun, of a different balance of metals, a different history of heat. To astronomers, it is a sample from another nursery of worlds, a message carried across light years without intention, just persistence. As it nears our solar system, its path curves subtly. The Sun's distant pull begins to whisper to it, faint but insistent. A thread of gravity catches it, not enough to capture, only to bend its motion. You picture it crossing the Oort cloud, that farthest region of frozen fragments, the outer skin of our solar family. For billions of years, those fragments have circled quietly, each one a silent relic of creation. Now, a stranger passes among them, tracing a new geometry through their field. Somewhere in that borderland, our Sun begins to rise in its sky. At first, only a faint glimmer, another star among many. But slowly, the light grows stronger, a subtle gradient across the black. The traveler has no eyes to see, yet its frozen atoms respond. Molecules vibrate with the first trace of heat. You imagine that warmth as a kind of welcome, the way the horizon brightens before dawn. You breathe, letting your body mirror that motion. Each inhale a drift inward, each exhale a release back outward. You, too, move between centers, between days and nights, between thoughts and dreams. The comet's path becomes your meditation, the long, slow arc of approach, not to conquer or settle, but to witness. Astronomers now track its course with care. They trace its hyperbolic trajectory, the kind that never closes, never repeats. It will visit only once. A single crossing through the solar system, then gone again, back to the darkness between stars. The data confirms what intuition whispers: this is not a comet born here, not one of our own. Its speed is too high, its orbit too open. It is truly from elsewhere. And so you think about distance, not the distance measured in kilometers or light years, but the emotional distance between the known and the unknown. How easily curiosity bridges it. When you gaze at the stars, that same bridge forms in your mind. The unknown stops feeling distant. It becomes intimate, something you can almost touch, almost feel. The comet's journey becomes a reflection of your own curiosity, the constant reaching toward what lies beyond familiarity. You imagine it gliding past the frozen worlds at the edge, past Pluto, past the Kuiper belt, past the region where sunlight fades to starlight. Its motion is slow but sure, each kilometer a small act of persistence. Somewhere ahead lies the Sun, a beacon drawing it inward. Somewhere behind stretches everything it has left behind, an entire star system now invisible, forgotten, but never erased. It is strange comfort to think that even an object flung from its origin can still find meaning in its passage. Its path, though vast and solitary, becomes part of our story now. For a few brief years, it will belong to our observations, our wonder, our collective imagination. And then, like a thought passing through the mind, it will move on. You close your eyes and picture its motion, a glowing speck crossing the interplanetary sea, silent and serene. You imagine its speed, tens of kilometers per second, yet it does not feel fast. In the scale of space, even that rush feels like drifting. You breathe slower. The calm of the comet's pace seeps into you, until your thoughts move as gently as its orbit. Somewhere far ahead, the Sun waits, its warmth growing stronger with each passing day of travel. The moment of meeting will come soon, light touching ice, awakening chemistry, revealing secrets frozen for billions of years. And as the traveler glides inward, you can almost feel that moment forming, the delicate transition from darkness to light, from stillness to motion, from silence to the first whisper of transformation. You exhale softly, and the question rises like a spark in your resting mind. What happens when the Sun finally reaches the surface of this ancient wanderer, and begins to change what has been unchanged for so long? The traveler drifts inward, its path curving gracefully toward the Sun. It carries with it more than motion. It carries memory. You imagine its surface, dark, rough, unshaped by atmosphere or weather. A relic sculpted only by time and radiation, wrapped in an ancient quiet. Inside, beneath layers of carbon dust and frozen gas, lie secrets from another star's beginning. They are not words or symbols, but arrangements of atoms, the frozen handwriting of creation. You picture that ancient birthplace, a swirling disk of gas and dust surrounding a newborn star. Within that mist, countless grains collide, stick, and grow. Some melt into droplets of rock. Others coat themselves in frost and drift outward, where cold reigns. It was in such a nursery, long ago and far away, that this traveler formed. Each speck inside it once floated freely, carried by eddies of gas, touched by starlight, cooled by distance. Then gravity gathered them, one particle at a time, into a larger and larger body, until what was once dust became a worldlet. You breathe slowly, imagining that process happening again and again across the galaxy. Every star, every system, every world, born from dust. And you, too, are part of that lineage. The carbon in your cells, the oxygen you breathe, the iron in your blood, all once drifted as grains in a cosmic cloud. In the comet's ancient ices, you recognize your own ancestry. The same ingredients, only colder. The same story, only told in silence. As the sun grows brighter, something stirs within the traveler. The ices inside, frozen carbon dioxide, methane, ammonia, perhaps even water, begin to respond. These are not like the ice in your glass or on your winter window. They are fragile, volatile, and sensitive. At just the hint of warmth, they begin to sublimate, changing directly from solid to gas. You picture it like a deep sigh, released after an eternity of stillness. The gases seep through cracks and fissures, carrying dust along with them. Together, they form a faint coma, a ghostly atmosphere surrounding the solid core. It's the first sign of awakening. For billions of years, these molecules have been asleep, untouched by light. Now, under the sun's gentle invitation, they rise into motion. A transformation begins, quiet yet profound, from cold stone to living spectacle. Astronomers watching from Earth detect these changes through spectra, delicate lines in light that tell of carbon, oxygen, hydrogen. Each line is a signature, a whisper of chemistry. Through those lines, they learn what the comet is made of, what ices evaporate first, what compounds glow in sunlight. Every observation is like listening to the traveler breathe. You imagine standing on its surface, if such a thing were possible. The horizon curves close, the stars are sharp and unwavering. The sun, still distant, glows as a pale fire in blackness. Around your feet, dark ice begins to glisten. You can almost hear the faint crackle of sublimation, a sound so quiet it might be mistaken for your own heartbeat. The air is non-existent, yet the space around you vibrates with potential. Inside the nucleus, layers of history remain untouched. Each meter deeper is another epoch, another chemical memory. In those frozen strata are clues about the star that once shone on its home system, about the elements that swirled around it. Some regions may be richer in carbon monoxide, others in ammonia or formaldehyde. These are the building blocks of organic chemistry, the same molecules that would one day seed planets and, perhaps, life. You think of that, how a small, cold body can carry the seeds of complexity. How simplicity, hydrogen, oxygen, carbon, rearranges itself into everything you know. The comet is not alive, but it carries the potential of life's ingredients. It is like a library of possibility drifting through the galaxy. And when sunlight touches it, the library opens, pages turning in vapor and dust. You breathe in, slowly. The air around you might feel ordinary, but it carries the same atoms once locked inside stars, the same chemistry unfolding in that distant traveler. There is no real separation, only difference in temperature, in place, in time. You are made of what the universe once scattered, and what it still carries. That thought feels calming, grounding, infinite. Back in the telescope's view, 3i Atlas glows faintly, no longer just a point but a blur. Its coma spreads, sunlight reflecting off microscopic dust grains. Scientists compare its spectrum to that of other comets, those born within our solar system. The chemistry is similar, yet subtly different. Ratios of carbon and oxygen shift. The balance of ices seems unfamiliar. It suggests a world formed in colder regions than ours, under a different kind of light. That small difference reshapes understanding. The solar system, it seems, is not the only recipe. You reflect on that truth, that variation is not error, but creativity. The universe never repeats itself. Every star, every planet, every grain of dust is an experiment in existence. This traveler is one such experiment, a frozen poem written in the dialect of another sun. And now, for a moment, it shares that language with us. The sun's rays continue their approach. The coma thickens, flowing outward like a slow breath. Dust drifts into space, forming a veil around the nucleus. Each particle catches light and releases it again, creating the faint shimmer that observers see through their lenses. It is as if the comet is remembering, awakening pieces of itself long forgotten. And as you watch it in your mind, you feel the same stirring. The memory that you, too, come from something ancient. That within your cells lies the same dust that once circled stars, froze in darkness, and now glows again. You are part of that endless cycle: birth, drift, return, renewal. The comet glides on, gathering warmth, shedding silence. Its secrets begin to loosen, one molecule at a time. And you, resting beneath your own star, feel that quiet unfolding mirrored inside you. The ancient and the present touch, just for an instant. You breathe once more, gently, as the traveler draws nearer still. Soon the sunlight will grow strong enough to sculpt tails, to scatter dust across space, to reveal the full beauty of motion and heat. But for now, it drifts in transition, between ice and vapor, memory and expression, a being caught mid-transformation, whispering softly through the void. And as you drift towards sleep, one question lingers like faint starlight on water. What shape will its awakening take when sunlight fully claims it? The sun's light stretches outward, billions of kilometers away, thin but patient. It reaches the traveler like a memory crossing time, a whisper of warmth, barely a breath in the void. The object, once cold and inert, begins to stir. Its surface, coated with ancient frost, awakens under the distant caress of sunlight. Molecules that have lain still for eons now tremble with new energy, vibrating, loosening, remembering movement. You imagine it, a slow exhale from stone and ice, invisible at first, then growing into a delicate veil of vapor. It's not fire or explosion but something quieter, gentler, the solid turning to breath, the hidden becoming seen. This is sublimation, the quiet chemistry of transformation, where frozen gases leap directly into vapor without ever becoming liquid. It's a dance that takes place not in noise but in patience. You picture the ices, carbon dioxide, water, ammonia, methanol, fragile compounds born in the chill nurseries of distant stars. They have waited in this traveler's body since before our own sun ignited. Now, one by one, they lift away, each molecule a note in a soundless song. If you were to drift nearby, safely cocooned in your imagination, you would see the faint shimmer of dust carried upward. The sunlight catches those grains, scattering faint halos. The object, once dull and dark, now wears a soft glow, a luminous envelope forming around it. It begins to resemble the comets you've seen in pictures, a fuzzy body with a breath of mist around it. But this is no ordinary comet. It is a wanderer from another star, and the chemistry that drives this sublimation may hold secrets from far beyond the edge of our system. You watch, inwardly, as the first plume rises, and feel an echo of that motion within yourself. There is something profoundly soothing about this kind of change. Not forced, not hurried, simply the natural release that comes when warmth returns after a long cold. You might think of your own life, the moments when something buried deep within you begins to thaw. Old thoughts, old memories, they rise softly, released not by effort but by the quiet presence of light. The traveler continues its approach. It is still far from the sun compared to the inner planets, yet even here, the balance tips. Solar radiation, photons streaming at the speed of light, strikes the surface. The energy absorbed is enough to break the bonds holding ices together. Each molecule that escapes carries away a whisper of heat, cooling the surface again, creating a delicate equilibrium. Warming and cooling, giving and releasing, a gentle cycle. This is what the astronomers call outgassing, but the name feels too mechanical for something so tender. You imagine it instead as breathing, the object inhaling sunlight, exhaling vapor. A slow, cosmic respiration. The rhythm of this breathing is older than any heart you know. Dust particles, freed by the escaping gas, drift outward and begin to form a coma, the bright halo that marks a comet's living stage. Some of this dust may spiral, tracing faint paths behind, shaping what will soon become a tail. Yet at this moment, it is still modest, still new, like the first brushstroke on a vast painting. The traveler's orbit curves, its path dictated by gravity but sculpted now by sunlight's pressure too. The escaping gases act like tiny thrusters, subtly changing its motion. It's as though the object, by breathing, alters its own fate, an image that feels almost human. You exhale, feeling your own breath as part of this same pattern, release and redirection. You think of the invisible physics guiding this process. Every molecule escaping carries momentum. Every photon that bounces off dust transfers a hint of force. The universe, vast and quiet, is never still. Everything moves, everything responds. And you, floating in your imagination, become aware of your own sublimation, thoughts dissolving into stillness, distractions lifting away. You are no longer confined by the heaviness of the day. The warmth of the sun, though millions of miles away, feels close, like a small flame at the edge of your consciousness. The object's surface transforms unevenly. Some regions flare into activity, others remain cold. Jets form, narrow plumes of gas that burst from cracks, spinning the body gently. In that rotation, the visitor reveals its complexity, not smooth or simple, but rugged, facetted, alive with physics. Its surface glitters in places, shadowed in others. From far away, telescopes on Earth capture only a faint point of light, but within that point lies the whole story of energy meeting matter, of warmth meeting cold, of time unfolding. There's beauty in that distance. How so much wonder can exist in a pixel of light. You imagine the astronomers watching through their instruments, patient and quiet. They know that even faint brightness holds deep messages. The changing brightness tells them how fast the traveler spins, how its shape might be irregular, how its surface changes as it breathes sunlight. It is strange to think that something so small can hold the attention of an entire planet's worth of curiosity. And yet, that's what the cosmos does. It takes our attention and expands it. It asks us to look farther, slower, gentler. The sublimation continues, steady as a whisper. Every second, tons of material drift into the void, spreading like incense in a temple with no walls. You sense that the traveler is both vanishing and revealing itself at once. What leaves its body allows us to see its nature. What it loses becomes what we know. You think again of your own life. How often what you release, a thought, a habit, a grief, allows your true form to appear. The act of letting go is not loss, but illumination. You, too, are a body warmed by light, shedding what is no longer needed. Far behind the traveler, its trail of dust begins to stretch into a faint filament. If you could see it from above, it would appear like a soft thread weaving through the blackness. The sun, steady and ancient, watches from afar, indifferent yet nurturing. In this relationship of distance and warmth, the visitor's story continues. The transformation is silent. Space carries no sound. Yet if you listen closely, not with your ears but with your imagination, you can almost hear the rhythm of molecules escaping, the faint hum of radiation, the sigh of creation renewing itself. Every process in nature, no matter how small or vast, speaks the same language: change. And change, when seen without fear, becomes an art form. The sublimation dance is the universe's slow choreography, patient, continuous, full of grace. As you rest in this thought, your mind drifts with the dust plume. You feel light, diffuse, no longer bound by the edges of your body. The boundary between your breath and the object's vapor blurs. You, too, are part of this exhalation. The sun glows gently in your inner sky. You sense the next phase coming, a deeper look at what these gases hold, what chemistry emerges from their release. What stories they tell of distant origins, of stars you'll never see yet somehow know. You exhale one last time, soft and slow, and let your awareness hover beside the traveler as it continues to breathe. In the quiet wake of this sublimation, you begin to wonder what secrets lie within those vapors. What chemistry of the unexpected might be revealed when the light meets the unseen. You sit again in the quiet of the night, the memory of light from the previous chapter still soft behind your eyelids. The comet, 3I Atlas, is no longer only a distant spark. It is breathing, releasing its first gases into sunlight. Yet what it breathes is not what scientists had expected. It speaks in a different chemical language, one that reminds you how the universe loves variety, and how even the most familiar processes can hold surprises. In the warmth of the sun, the ice of the comet begins to change. Molecules locked in stillness for eons tremble, loosen, and leap into motion. You picture it as a ballet of invisible dancers: carbon dioxide, carbon monoxide, bits of frozen hydrocarbons, each spinning away into space in a cloud of glittering dust. Astronomers look for the telltale fingerprints of these molecules through their instrument. The carbon dioxide that drives the comet's activity is a molecule of simplicity and elegance. One carbon atom, two oxygen atoms, bound together. On Earth, it is the gas of breath and fire, of volcanic release and exhaled life. In the comet, it becomes an engine of transformation, sublimating under sunlight, expanding into vapor, lifting dust from the nucleus, and painting a faint halo around the traveler. The same molecule that leaves your body in every breath now shapes the beauty of a cosmic visitor millions of kilometers away. You are, in a subtle way, participating in the same dance. Astronomers studying the spectra of 3I Atlas notice the faint ratio between water and carbon dioxide, noting that water, usually dominant, seems subdued. In that quiet discrepancy, questions arise. Perhaps this comet formed in a region colder than the typical ice line of its home system, where water froze out completely and only more volatile gases remained. Or perhaps its birthplace had a different chemistry altogether, where oxygen and hydrogen never combined freely as they do around our sun. The possibilities bloom like ripples on still water, each one suggesting a new landscape, a new star, a new world. You imagine these distant worlds, the cold outskirts of alien systems, where sunlight is dim and the air never moves. You see rings of dust and ice swirling around newborn stars, the beginnings of planets glimmering faintly. Somewhere in that swirl, a small fragment like 3I Atlas forms, then, one day, is flung outward by the gravity of giants, exiled into the dark. You see how that exile becomes freedom, and how freedom becomes discovery. Your thoughts drift to your own chemistry, to the unexpected ways in which you, too, contain contradictions. You are made of delicate balances, warmth and calm, carbon and oxygen, emotion and reason. Within you, like within the comet, nothing is as simple as it seems. You are composed of histories, of moments of pressure and release. The body that breathes in rhythm with the cosmos carries its own volatile mixtures, waiting for sunlight, in whatever form it comes, to awaken them. The comet's strange composition reminds scientists that classification is a convenience, not a truth. Labels serve until nature outgrows them. Just as your understanding of yourself changes with time, so too must science remain open to being surprised. The beauty of discovery lies not in confirming what you expect, but in realizing how much remains unknown. In this gentle awareness, you find peace. The unknown does not have to be feared, it can be an invitation to wonder. You think of the astronomers again, their instruments turn toward the faint, glowing smudge that is the comet's coma. Each spectrum, each trace of light, tells a story written in wavelengths. They listen, quietly, to those colors, decoding their message. And in doing so, they participate in something sacred, the act of listening to the universe without judgment, allowing it to speak for itself. Outside, the night deepens. The stars are steady, their light crossing distances beyond your comprehension. Somewhere out there, more such visitors travel unseen, each with their own chemistry, their own unexpected stories. The galaxy becomes, in your imagination, a vast garden of variety, each system a different flower, each comet a seed carried by cosmic wind. Some will drift toward suns like ours, others will vanish into darkness, never to be seen again. Yet each one contributes to the endless experiment of creation. The more you think of it, the more comfort you feel. To live in a universe where everything follows a pattern would be lifeless. It is the differences, the small deviations, the quiet surprises, like 3i Atlas and its chemistry, that make the cosmos alive. The unexpected is not an error. It is a sign that something new is being revealed. You exhale slowly, feeling your own breath join the invisible tide of gases around you. Carbon dioxide leaves your lungs, drifts into the air, joins the great cycle of atmosphere and life. Somewhere, far away, the same molecule leaves the comet's surface and drifts into sunlight. For a brief instant, one impossible, beautiful instant, you and the comet are breathing together. And as you rest in that image, you sense another truth beginning to rise, that the chemistry of the unexpected is not only out there, in the stars and comets, it lives within the long rivers of time themselves, waiting to carry you into deeper understanding. You close your eyes and imagine time not as numbers or clocks, but as a flowing river. Some parts move swiftly, like mountain streams, others slow, deep, and quiet. The comet 3i Atlas, still drifting through sunlight, belongs to the slower current, one that began long before our own solar system formed. It has been traveling through the galaxy for billions of years, carrying frozen material from an era when stars and planets were only beginning to appear. Thinking of that time stretches your sense of the present, as if you could see the full river from its distant source to where it passes by you now. Scientists studying 3i Atlas estimate that its age may exceed that of the Sun by many hundreds of millions of years. The evidence lies in its chemistry, its orbit, and its untouched, unprocessed material. The object was likely formed in another stellar nursery, a dense cloud of gas and dust where gravity pulled matter together, forming a young star and its surrounding disk. Somewhere in that disk, a small clump of rock and ice condensed, orbiting peacefully until a larger planet's pull ejected it into the interstellar void. From that moment, its journey began. You picture that moment clearly, a faint disk swirling around a new star, particles colliding and merging, gravity guiding them into new shapes. Then, a sudden interaction, perhaps with a gas giant, sends a small icy fragment outward, past the edge of its solar system, into open space. That ejection, though violent, is part of a cosmic rhythm. Every system produces wanderers. Every beginning releases something into the vastness. The comet became one of those wanderers, crossing the space between stars like a seed carried on a galactic breeze. Over billions of years, the Milky Way itself has moved, rotated, and evolved. Stars have died and been born again. Yet the comet kept moving, untouched by all that activity, isolated but preserved. Its interior remained frozen at temperatures near absolute zero. Molecules that formed in its home system never changed, never mixed, never broke apart. They stayed exactly as they were at the beginning. To study such an object is to touch deep time, to hold something that remembers conditions from before our own sun was born. When astronomers analyze the orbit of 3I Atlas, they see that it is hyperbolic, not bound to our sun's gravity. That orbit tells them it came from far beyond the edge of the solar system, from interstellar space itself. You imagine its path, curving slowly inward, bending gently around the sun, and then departing again, forever. For a few brief months, its journey intersects ours. Then it continues its endless drift, like a leaf caught for a moment in an eddy before being carried on downstream. The idea that this object is older than the solar system changes how you see time. You think about how human lives are measured in years, decades, or generations. Tiny ripples on the surface of this deeper current. The comet has seen whole epochs pass, the birth of stars, the clustering of galaxies, the cooling of dust clouds. It reminds you that time is not only something you move through, but something that moves through you. Scientists use isotopic analysis and models of galactic motion to understand how long such an object might have traveled. Over 1 billion years, even small gravitational nudges from passing stars can alter its course, sending it toward regions where other systems lie. Perhaps 3I Atlas passed near hundreds of stars before reaching ours. Each encounter left a subtle mark on its trajectory, a quiet reminder that everything in the galaxy is connected through motion and influence. You begin to see the galaxy itself as a network of rivers, billions of streams of time and motion, each carrying objects, light, and energy. The comet is one of countless travelers moving along these currents. Some are comets, some are dust grains, some are even whole stars pulled by gravity's invisible hand. Time flows not in straight lines, but in wide spirals and arcs, folding back on itself as it circles the galactic center. It can be hard to imagine billions of years, but the comet helps you visualize it. Every kilometer it has traveled, every rotation it has made, adds to the silent record of its existence. You can almost sense its patience, the way it endures without needing to hurry. In comparison, your own life feels brief but meaningful. The comet's vast age does not diminish your smallness. It makes you aware of your place in a much larger process. Inside that awareness, there is calm. Time becomes less of a force to fear and more of a landscape to wander through. You realize that deep time holds everything, beginnings, transformations, and endings, but none of them feel rushed. The comet, with its long journey and unchanging nature, embodies that stillness. Its frozen ices, older than our sun, are like the ancient memories of the universe itself, carried intact through eras of change. In scientific terms, 3I Atlas offers data about the conditions of other planetary systems' birthplaces. The isotopic ratios in its gas might reveal how that system's star formed, what elements were abundant, and how materials condensed. Every molecule escaping from its surface is a messenger from a different era. You imagine scientists studying those faint traces, translating them into a timeline of cosmic events. For them, the comet is not just a visitor but a record, an ancient archive floating through the galaxy. You think again of the river of time. If the early universe was its source, then stars and planets are like eddies where matter gathers briefly before dispersing again. The comet's journey through that flow shows that nothing truly stands still. Even when frozen, even when alone in the dark, everything moves with the current of time. And yet, within that motion, there is continuity. The carbon, oxygen, and hydrogen inside the comet are the same elements that exist within you. They have flowed through countless forms, through stars, through clouds, through living things, and continue to circulate. You are part of the same river, shaped by the same deep processes that sculpted 3I Atlas long before Earth existed. As you rest in that thought, you feel the difference between clock time and cosmic time. Clock time counts the seconds of your days. Cosmic time drifts, almost still, carrying the story of everything across eons. When you think of it that way, your heartbeat feels like a small echo of a much greater rhythm, one that pulses quietly through stars, comets, and galaxies. The comet continues its journey, sunlight fading on its surface as it moves away. Its gases thin, its activity slows, and soon it will return to silence. But its story does not end there. Somewhere ahead, it will cross another current of gravity, another field of starlight. Time will keep flowing around it, and it will keep drifting, unchanged. You exhale slowly. The comet's path becomes a reminder that all things, even the smallest and briefest, are part of a much older continuum. The moments you live are threads in a pattern that extends far beyond sight. You cannot see the beginning or the end of that river, but you can feel its movement beneath you, quiet and steady. As you imagine drifting along that vast current, your thoughts begin to soften. The boundaries between seconds and centuries blur. You are floating in time's deep water now, unhurried and weightless. And somewhere ahead, the river bends again, toward the next reflection, the next realization, toward a moment when you will see your own solar system mirrored in this visitor's ancient memory. You watch the visitor's path unfold like a long-forgotten reflection. In its movement, you see echoes of how our own solar system began, dust swirling, gas collapsing, light finding its first warmth in darkness. The object glides silently, yet within that silence, it tells a story older than planets, older than the comfort of the sun's steady glow. You begin to understand that what we observe out there is not separate from us. It is a mirror, quietly showing us where we come from. Our solar system was once a cloud, a drifting sea of dust and gas orbiting nothing. Then, one day, gravity whispered, and the cloud began to collapse. It spun, flattened, and brightened, becoming a disk of creation. Within that disk, small grains collided, clumped, and stuck together. They formed planetesimals, then protoplanets, and finally, the worlds we now call home. Jupiter took its throne early, its great gravity shaping the fate of countless smaller bodies, while Earth, in its tender orbit, gathered the elements that would one day breathe life into you. As you picture this, you sense how calm chaos can be, how creation is both turbulent and serene. The visitor now moving through our skies once drifted through its own version of that chaos. In another system, another star once kindled light into dust. Its planets, if they ever formed, followed paths unseen by our telescopes. Something, perhaps a close encounter, perhaps the stirring of a giant, cast this fragment free. It wandered into the long night between stars, where the distances grow immeasurable and time itself stretches thin. Now, millions or billions of years later, it crosses our path. When astronomers first plotted its motion, they saw it did not loop around the sun like a comet born here. Its trajectory was open, an arc that would enter and then leave forever. That shape told them everything. This was not one of ours. It had come from elsewhere. And in that realization, a mirror appeared, not of glass or light, but of story. Because to understand it, we must remember our own beginning. The visitor holds within it traces of its birthplace. Perhaps the ratio of hydrogen to heavier elements, the composition of its dust, or the crystalline structure of its ices speak of the temperature and chemistry of another nursery. Every observation we make reflects back upon our own. By comparing its material to the comets and asteroids of our solar system, we learn what is unique to us, and what is universal. You breathe slowly, imagining the sun's gravity tugging on this wanderer, ever so slightly bending its path. That same pull shaped everything you know, the orbit of your planet, the rhythm of your seasons, the dance of tides. The visitor, in turn, shows how gravity reaches beyond the familiar, stitching together the entire galaxy with invisible threads. You begin to feel that connection, not as a distant idea, but as something living inside you. The atoms that form your blood, your skin, your breath, all once drifted in a cosmic cloud, waiting to be gathered into meaning. In that sense, this object is family. Its story and ours diverged long ago, but the origin is shared. The same processes that shaped its minerals shaped your bones. The same starlight that warmed its icy surface once kindled atoms that became your heartbeat. You and it are both the outcomes of patient physics, matter learning, over billions of years, how to form structure and memory. You imagine standing somewhere quiet, away from city lights, gazing up. The stars above you form their own disk, the Milky Way, our galactic home. Within that pale band lie countless other systems, each a laboratory of possibility. Somewhere, around one of those distant suns, a similar observer might look toward our star and see one of our comets pass by, wondering, what does it tell us about the solar system it left behind? In that wondering, two civilizations, separated by light years, could share a moment of reflection, each seeing itself in the other's sky. The more we observe the visitor, the more we learn how varied planetary systems can be. Some stars form with giant planets close in, others fling debris outward. Some harbor stable, circular orbits, others birth worlds on tilted, eccentric paths. Yet through all this diversity, the same forces are at work: gravity, motion, heat, and time. The same principles that guided dust into worlds now guide you into understanding. Our solar system story is not the rule. It is one example among millions. When we study an interstellar object, we see not only what it is, but what we might have been. If Jupiter had formed differently, if the early disk had spun faster or slower, perhaps Earth would not exist, or life might have arisen under another sun entirely. The mirror does not flatter or diminish. It simply reveals that creation is vast, varied, and ongoing. The visitor continues its silent curve, gathering light and leaving questions. Its surface, likely pitted and ancient, has recorded collisions and cosmic rays over eons. Each mark is a word in a language of formation. When scientists study its color, its reflectivity, its changing brightness, they read that language one letter at a time. You, too, can read it, through imagination, through empathy, through the quiet understanding that the cosmos writes in patience. In this reflection, you begin to sense something tender. The universe does not repeat itself, yet everything within it rhymes. The atoms in you rhyme with the atoms in this traveler. The same energy that powers the sun once stirred in another star that gave birth to the wanderer. You are living proof that the story of formation never ended. It merely changed form, from dust to consciousness, from chaos to curiosity. You close your eyes for a moment and breathe in that realization. The mirror is not only out there, it lives in the space behind your thoughts, in the calm rhythm of your heartbeat echoing the cycles of celestial motion. Every inhale is gravity pulling inward, every exhale is release, the same eternal dance that governs planets, comets, and galaxies. As the visitor drifts deeper into the solar system, scientists continue to measure, to hypothesize, to dream. Yet even in their data, there is a quiet beauty, a sense of being part of something immense and continuous. You realize that understanding is not separate from wonder. The more we learn, the more mysterious everything becomes. Somewhere in that gentle paradox, you find peace. You don't need to know every detail to belong. You are already part of the story you seek to understand. The mirror reflects both ways, you looking outward, the cosmos looking back. And as the light of the visitor fades into the dark between worlds, you wonder softly, what rhythm of motion guides its path now, and what harmony of forces keeps this endless cosmic dance alive? You imagine the solar system not as stillness, but as motion, everything in quiet, perpetual dance. Each world, each fragment, each grain of dust follows a rhythm so ancient it has become the very heartbeat of the cosmos. The interstellar visitor, gliding on its steep, fleeting path, joins this choreography for a brief moment. Its speed, its tilt, its trajectory, all become part of an invisible symphony composed by gravity itself. The solar system moves like a great clock, but one built not of gears, but of orbits. Each planet, comet, and asteroid marks time in its own way. Mercury spins quickly, close to the sun's warmth. Neptune drifts slowly at the edge, patient and cold. Between them lies a balance, forces pulling, curving, maintaining harmony. Gravity binds it all, the unseen musician that keeps every body in rhythm. You picture this dance in your mind's eye. Lines curve and spiral, each representing an orbit. The visitor's line is different. It cuts through the others, steep and open-ended, an uninvited yet welcome guest. As it passes, it alters slightly the rhythm of those around it. The sun's gravity bends its path, while in return, the visitor's own faint pull tugs ever so gently on our system. The effect is almost imperceptible, yet it exists. In this way, nothing in the universe ever moves alone. You think of how these forces work. Newton described gravity as attraction, a pull between all masses. Einstein later reshaped that idea into something deeper. Space itself bends around mass, and what we call motion is really a body following the curves of that bent space. The planets are not being tugged by invisible strings, they are simply moving through a landscape shaped by the sun's presence. And so, too, does the interstellar traveler follow its own slope, curving gently through the sun's invisible valley before continuing outward into the wider galaxy. You begin to feel this not just as an idea, but as something inside your body. Your heartbeat, your breathing, even your thoughts move in rhythms, patterns guided by invisible balances. The same natural law that keeps the Earth circling the sun also keeps your blood flowing through its loops and cycles. You are not separate from this dance. You are part of it, a smaller reflection of its balance and grace. In this cosmic ballet, energy is never still. Kinetic energy, the energy of motion, and potential energy, the energy of position, exchange roles endlessly. When the visitor nears the sun, it accelerates, gaining speed, its kinetic energy rising. When it moves away again, that energy is traded back, converted into the effort of climbing out of the sun's gravitational well. Nothing is wasted, nothing lost. It is a perfect rhythm, fall and rise, approach and retreat. Astronomers track this motion with quiet precision. They measure tiny changes in speed, angles of approach, the shift of light from red to blue as the visitor moves toward and then away from us. Each number, each fraction of a degree, tells a story of motion and influence. From these observations, they map the shape of its journey, an open hyperbola, unlike the ellipses of our homegrown comets. A hyperbola means freedom. This traveler will not return. Its dance with the sun is only a passing bow before it drifts once again into the interstellar night. Yet even a passing encounter leaves traces. The gravitational tug of the sun slightly alters the visitor's path, changing its future by the smallest degree. That change, multiplied over millions of years of travel, could decide which star system it will pass next. Gravity is the universe's way of leaving fingerprints, gentle, continuous, invisible. You think of the planets, how they maintain their balance through delicate interactions. Jupiter, the giant, plays a central role. Its mass is so immense that it orchestrates the movements of countless smaller bodies. Many comets and asteroids owe their orbits to Jupiter's influence, its gravity either guiding them into stable paths or ejecting them entirely. The interstellar visitor's own journey may once have begun in such a system, perhaps thrown outward by the might of a massive planet orbiting another sun. What began as a stable orbit could have become an ejection, a slow but irreversible goodbye. The visitor now reminds us that our solar system, too, sends its own travelers into the dark. Some of our comets, perhaps long after you are gone, will drift beyond the sun's reach, carrying bits of our system's story outward. To another civilization, they might appear one day as this object appears to us, a stranger from the deep, whispering of other worlds. The dance never ends. The partners simply change. In the great scale of cosmic motion, Even stars move together in vast spirals around the center of the Milky Way. Our Sun, our planets, and this interstellar traveler all partake in that galactic rotation, orbiting the core where a supermassive black hole resides. The galaxy itself is a dancer, arms of stars sweeping through the darkness. You realize how vast the choreography truly is, how each movement is part of a pattern larger than imagination. You breathe slowly, in time with this imagined motion. Inhale as the traveler approaches the sun, exhale as it begins to retreat. You are practicing, without effort, the rhythm of gravity itself, an ancient balance of falling and release. The dance is both mechanical and mysterious, predictable and profound. Its steps are written in the equations of motion, yet its beauty lies in the quiet grace with which those equations unfold. Even chaos has a role in this dance. Tiny differences in position or velocity can lead to entirely new outcomes over time, a phenomenon scientists call chaotic dynamics. Two nearly identical comets may, after centuries, end up on wildly different paths. Yet chaos does not mean disorder. It means sensitivity, responsiveness, the system's ability to evolve endlessly from simple beginnings. You find comfort in that thought. Even unpredictability can belong to harmony. As the visitor moves on, its presence changes us, too. Not in our orbits or tides, but in understanding. We are reminded that every motion in space is connected. Every force, no matter how small, participates in the same universal dance. From galaxies colliding to an apple falling from a tree, it is all one choreography, written in the same invisible ink. You let this realization settle over you like calm water. The universe is not a place of chaos, but of patterns. You belong to one of them, even as you breathe quietly in the dark. Motion is not something to be feared, it is the natural way of things, the pulse of existence itself. The visitor's path now begins to curve outward again. Its speed is great, yet not frantic. It is simply obeying the shape of the sun's gravity, following the most natural arc. It will soon be gone, heading toward another region of the galaxy. But for this brief time, it has shared our space, joined our rhythm, and taught us that harmony does not require permanence. And as it drifts farther, leaving the sun's warmth behind, you wonder softly, what does it mean, truly, to come from beyond our star, and how far does belonging extend in a universe where everything moves together? The word interstellar carries with it a quiet awe. Between the stars, that is what it means. To come from those cold, unlit distances where the gravity of no single sun reigns. You picture that vast space, the true in-between, where the nearest light is only a distant whisper and darkness has its own texture. There, a traveler drifts, alone but steady, carrying within it the stories of another system, another time, another beginning. You imagine 3i Atlas in that solitude, long before it reached our sun's domain. It might have spent millions, even billions, of years coasting through interstellar space, untouched, unheated, unseen. No light to reflect, no heat to awaken it. Just the gentle, endless glide through emptiness. Its motion was not aimless, though. Momentum itself is purpose, the continuation of what began long ago. Somewhere, long ago, it was born from dust, ice, and gravity around another star. And somewhere in that distant system, a gravitational encounter, perhaps with a giant planet, gave it the energy to escape. You think about that moment of escape. To leave one star is to be given freedom, but also to lose home. This is not a sentimental thought, it's simply the physics of detachment. When a planet or a comet gains just enough velocity, it crosses a boundary where the star's gravity can no longer pull it back. Beyond that limit, it becomes interstellar, unbound. The same laws that once kept it circling now send it outward forever. Our visitor has crossed that line twice, first to leave its birth system, and again to enter ours. It is both foreign and familiar, carrying reminders of how worlds begin, yet written in a dialect slightly different from our own solar tongue. The chemistry of its ices, the ratios of carbon to oxygen, the subtle fingerprints in its light, each of these speaks of another nursery, a distant forge where elements gathered and froze in patterns that differ from those near our sun. Being interstellar is not just about distance. It's about origin, about the diversity of creation across the galaxy. Every star hosts its own family of worlds, comets, and debris, sculpted by its particular balance of gravity, radiation, and time. If you could drift from one system to another, you would find familiar shapes, disks, planets, comets, but never quite the same materials, never quite the same arrangement. The universe repeats its ideas but never copies them exactly. You reflect on how much of astronomy is about tracing these origins. When scientists study 3I Atlas, they are really listening to a messenger from another star. It carries no words, no deliberate signal, yet its motion, color, and gas tell us stories if we learn how to read them. That is what science often is, the art of listening carefully to things that do not speak. To be interstellar is also to belong to no single place. In that way, this traveler resembles you more than you think. Your body, too, is made of atoms that once belonged elsewhere, carbon forged in the death of a star, calcium from supernovae, iron from ancient stellar cores. Every bit of you has traveled across time and space to be here. The comet's journey is a grand version of that same truth. Everything in the cosmos is transient, passing from one form and one home to another. You picture again the dark between the stars. It is not truly empty. Even there, in the deepest cold, atoms of hydrogen drift, sparse and quiet. Invisible magnetic fields thread through the void. Stray photons cross from distant galaxies. And now and then, a wanderer passes, a rock, a shard of ice, a traveler like this one. The galaxy is not a set of isolated islands. It's an ocean of slow connections, each crossing unseen but significant. When astronomers call something interstellar, they are acknowledging its independence. It is not gravitationally bound to the sun. It does not circle. Its path is open-ended. That openness carries both beauty and melancholy. The object will visit only once. It will never return. Its entire encounter with us is a single sweep of its trajectory, an instant in cosmic time. For scientists, this one pass is precious. They must observe quickly but carefully, gathering light while it's still within reach. Telescopes across the world coordinate, watching from dusk until dawn. Spectrographs dissect the faint colors of its coma, radio dishes listen for molecules in its outgassing, infrared eyes seek warmth. From these delicate traces, they reconstruct its story. The first interstellar visitor we ever recognized, Oumuamua, taught us that such travelers exist. 3I Atlas confirms it. The galaxy is not quiet, but alive with motion. There must be countless fragments drifting among the stars, relics of planetary systems forming and scattering. Most will never come close enough for us to see, but their existence means that the space between stars is not lonely. It is full of stories in transit. You let that image settle. The Milky Way becomes not a static spiral of light, but a living current of movement. Planets form and shatter. Stars are born and die. Comets are flung outward, carrying whispers of one system into the realm of another. Over billions of years, the galaxy mixes itself. Its material circulates like air, like water, like breath. You think of our own solar system's infancy, how countless icy bodies orbited far beyond Neptune, in the region known as the Kuiper Belt. Some of them, disturbed by passing stars or giant planets, were ejected into interstellar space. Even now, a few of those ancient fragments wander between stars. Somewhere, perhaps, a being in another world may one day glimpse one of them passing by and wonder, what does it mean to come from beyond? That thought feels gentle, not alienating. To be interstellar does not mean to be lost. It means to participate in the exchange that keeps the galaxy alive. Every fragment that travels outward brings knowledge, dust, and potential to new places. Even life's raw materials, carbon, water, amino acids, can be carried by such messengers. When they drift into a new system, they may contribute to the beginnings of something else. A comet, after all, is both traveler and seed. In this light, 3I Atlas is not just an outsider. It is part of a grand circulation of matter, an ambassador of cosmic continuity. Its chemistry, slightly unusual, reminds us that the building blocks of planets and perhaps life itself are scattered everywhere. We are not the exception. We are one of many outcomes. You rest in that thought. To be interstellar, in the deepest sense, is to belong to everything. The traveler has no single star to orbit, but the galaxy itself becomes its home. It drifts under the combined pull of hundreds of billions of suns, guided not by one gravity but by the collective shape of all. That, too, is a kind of belonging, a freedom within connection. You feel that same pattern reflected in yourself. You move through spaces, relationships, and phases of life, belonging in many ways but never confined to one. You are part of a vast system of exchange, of ideas, of memories, interstellar in your own quiet way. Now, as the object approaches the sun, sunlight begins to reach it again. The ices that have slept for eons will soon awaken. Outgassing will begin, and the quiet body will grow luminous. It will reveal its hidden materials in a brief show of light. And you wonder softly, as the warmth begins to touch it, what new shapes will this awakening take, and how do even frozen travelers learn to let go and shine? By the time 3I Atlas crossed the invisible threshold of the inner solar system, it had begun to change, not in essence, but in expression. The silence of the interstellar dark gave way to a faint hiss of energy, a subtle warmth that started to awaken the volatile materials buried deep inside its frozen heart. For millions of years, Atlas had been locked in the perfect cold between stars, where nothing stirred, and even time seemed to hesitate. But now, sunlight, the breath of our star, reached it once again. At first, the change was invisible. The surface remained dark and inert, the dust bound tightly by ancient ices. But slowly, as the solar photons continued to pour across its crust, something inside began to move. Molecules of carbon dioxide and water, once trapped in glassy prisons of ice, found enough energy to break free. The process was simple physics, sublimation, but on the scale of a comet, it was a transformation of identity. The solid became vapor. The motionless became alive. Jets of gas began to seep from fractures and pores in the nucleus, escaping into the vacuum and dragging tiny grains of dust with them. Each of these microscopic escapes contributed to the creation of something entirely new. The coma, the luminous cloud that would soon surround the comet like a ghostly aura. For the first time since leaving the cradle of its birth star, Atlas began to shine, not because it produced light, but because it reflected and scattered the sunlight it could no longer resist. Astronomers on Earth would soon notice the change. Through telescopes, they would see a faint blur where once there had been only a point of light. They would record the increasing brightness, estimate the rate of sublimation, and calculate the density of the coma. But for all the precision of numbers and models, no equation could capture the wonder of this awakening. To watch a comet come to life is to witness the most delicate conversation between ice and fire, distance and nearness, silence and radiation. The coma grew rapidly, expanding into a sphere tens of thousands of kilometers wide. Within it, particles collided gently, creating a diffuse veil that blurred the boundary between the comet and the cosmos. The nucleus, still a few kilometers across, was hidden somewhere deep inside, invisible behind its own exhalation. And then, as sunlight pushed harder, the next transformation began, the birth of the tail. Contrary to what our eyes imagine, a comet's tail does not trail behind it like a scarf dragged through space. Instead, it always points away from the sun, a reminder that the tail is not the result of motion, but of radiation. Solar photons and the charged wind streaming from the sun's corona exert pressure on the particles of dust and gas, pushing them outward in the opposite direction. Thus two tails often form. The ion tail, composed of charged particles, mostly carbon monoxide and nitrogen ions, glows with a bluish hue. It's shaped by magnetic fields carried by the solar wind, sometimes flickering, bending, or even snapping like a ribbon under unseen tension. The dust tail, on the other hand, shines golden or white, made of heavier grains that curve gently along the comet's orbital path, tracing a graceful arc across the sky. Together they form one of nature's most elegant structures, ephemeral, luminous, and vast beyond imagination. At its peak, 3I Atlas's tails stretched millions of kilometers across space. They shimmered in sunlight that had traveled 8 minutes from the sun, caught briefly by dust that had traveled 8 million years between stars. Each particle reflected a different moment of time, the ancient past of interstellar wandering and the immediate present of solar heat. The comet, for that brief interval, was both messenger and mirror, carrying the chemistry of another world into ours, while displaying the same physics that shaped every comet before it. But even as it grew more beautiful, Atlas was losing itself. Every plume of vapor, every grain of dust torn away by light, was a fragment of its own existence given up to brilliance. This was the paradox of comets. They shone most brightly when they were falling apart. Their beauty was inseparable from their destruction. The coma was a halo of evaporation, and the tail was a trail of loss. From the perspective of distant observers, it was a spectacle. From the perspective of the comet, if it could be said to have one, it was the process of dissolution, the slow unraveling of all that had been preserved for eons. Yet in that unraveling, something profound occurred. The material escaping from 3I Atlas joined the solar wind, mixing with the elements of our own star system. Hydrogen atoms, carbon molecules, silicate grains, all dispersed into the cosmic current, becoming part of the diffuse matter that fills the interplanetary medium. The interstellar visitor, through its disintegration, was merging with the environment it had entered. It was no longer entirely foreign. In this sense, the comet's outgassing was not merely a loss but a kind of communion. The space between stars was no longer a barrier, it was a bridge. The atoms born in one system now mingled with those of another. Perhaps, billions of years from now, when new planets formed from this mixed material, some fraction of 3I Atlas would reside in their rocks, their oceans, or even their living organisms. Comets are often called time capsules, but they are also seeds, not of life itself, but of its ingredients. The ices that sublimate into tails and comas contain the same building blocks found in the primordial clouds that once surrounded our sun: water, methane, ammonia, organic molecules. To watch these materials escape into sunlight is to witness the earliest chemistry of worlds replayed in miniature. Astronomers analyzing the spectra of Atlas's coma detected precisely these compounds. Each spectral line told a story, a dip in light where a molecule had absorbed a specific wavelength, a whisper from a substance older than Earth itself. In those thin traces, we could read the history of creation, migration, and return. By the time Atlas reached its closest point to the Sun, it had become a magnificent, glowing entity, its nucleus fragmenting, its tails streaming behind like banners of vaporized memory. And then, almost as quickly as it had brightened, it began to fade. The heat that gave it life also tore it apart. The nucleus fractured under the thermal stress, releasing cascades of dust that glimmered briefly before dispersing. Soon the glow dimmed. The coma thinned. The tails stretched into invisibility. But for a short while, as Earth turned and telescopes followed its motion across the constellations, the sky had held an interstellar visitor transformed by sunlight, a frozen wanderer from another star made radiant by ours. The process had a name: sublimation, outgassing, dissipation, yet what it truly represented was something more universal. The way all matter responds to energy, the way every encounter leaves a trace, the way even the most ancient traveler must eventually surrender to light. In its disintegration, 3i Atlas had revealed not just its structure, but its story. And as it faded beyond our reach, it left behind a question that would linger long after its glow was gone. If a comet from another star can become part of ours, what does it mean for any of us to truly belong? Night settles over the observatories. The wind at high altitude hums against the domes, and the world below fades into quiet darkness. You picture yourself there, standing at the threshold of a telescope dome, where metal and glass meet the infinite sky. The roof slowly opens, revealing a slice of the cosmos. Above you, stars shimmer, patient and unblinking, and somewhere among them drifts the interstellar visitor, faint, cold, and moving too quickly for the naked eye to trace. Astronomers move carefully. Every sound feels amplified in this stillness, the click of a control console, the whisper of a pen against paper. Their work is slow, deliberate, and deeply silent. You imagine them adjusting the telescope's long arm, calibrating instruments to capture a distant traveler no larger than a small hill, gliding through space at tens of kilometers per second. This is the kind of quiet that feels alive. It isn't empty silence. It's a silence that listens back. You sense that the universe, too, listens, to light, to movement, to time itself. Every photon that falls into a telescope's mirror carries a story. The astronomers know this, and tonight, they wait for those stories to arrive. The telescope begins to track. It moves so smoothly that you can hardly see it shift, but its precision is extraordinary. For hours, the system follows a dot fainter than imagination, an object not from our solar system but from another star's nursery. Its light is not truly its own. It reflects sunlight, carrying a whisper of our star's warmth into its cold, alien surface. In the control room, faint data streams appear, columns of numbers, waveforms, and spectral lines. You imagine the glow of monitors lighting up faces, the dim hum of computers interpreting signals that traveled millions of kilometers before touching the mirror. The data seems so abstract, so quiet, yet each line is a voice from beyond. The observers drink coffee in slow sips. They speak softly, if at all. Most of their work is waiting. Exposure after exposure, they collect faint trails of light. The world outside the dome sleeps, unaware of how close humanity comes, every night, to touching something immeasurable. You sit with that thought. Observation is an act of patience. It is also an act of faith, believing that what you seek will reveal itself if you simply remain still enough to notice. In that way, you are not so different from the astronomers. You, too, observe your own thoughts, your own passing patterns. Inside, there is a sky just as vast. The universe doesn't shout its secrets. It whispers them in starlight, in motion, in time. Astronomers have learned this rhythm, a dance between knowing and not knowing, between data and wonder. Their silence is not emptiness, it is space for understanding to emerge. You picture the photons entering the telescope mirror. They left the sun about 8 minutes ago, struck the object somewhere beyond the orbit of Mars, and bounced back toward Earth. In that moment of reflection, two stories met, one from our solar system, one from another. The detector captures that meeting, transforming it into digital memory. How astonishing it is, you think, that a single speck of light can carry so much meaning. Outside, frost begins to form on the handrails. The night is deep, and the stars appear closer, sharper. Somewhere, the interstellar traveler continues its path, indifferent, ancient, yet silently teaching. It doesn't know we're watching, yet our watching changes us. Observation creates connection. In looking outward, we learn something inward. The astronomers see not just data, but time itself, the echoes of the early universe written into spectra. You see not just the act of measurement, but the devotion it represents. Humans have always looked upward, wondering what lies beyond. You imagine what the telescope sees, the faint streak of light, moving slightly each night. Its orbit is hyperbolic, meaning it will never return. This is not a visitor bound by gravity. It is a traveler passing through, its journey spanning centuries between stars. The data confirms it, the trajectory, the speed, the slight shift in color due to motion. The object is real, measurable, and yet somehow, still a mystery. The astronomers check focus, recalibrate, adjust for atmospheric distortion. They are caretakers of precision. Each image, each observation, is a small act of preservation, a record of a moment that will never come again. They know that once the object leaves, it will vanish from our reach, fading into the same darkness it came from. For now, though, it is here. And they are watching. You imagine yourself sitting beside them, headphones off, breathing softly, eyes on the display. The monitor shows a faint smear of light among the stars. It looks like nothing. Yet in that nothing is everything: velocity, shape, reflectivity, composition. A whole story compressed into a few captured photons. Silence continues to fill the dome. It is not boredom but serenity, the kind that comes when humans and cosmos share a single purpose: understanding. You breathe deeply. Your own observation mirrors theirs. You, too, are watching, not a comet, but the quiet shifts of your own mind. Thoughts appear like faint stars, some bright, some barely visible. You let them drift without judgment. You realize, the act of watching is itself an act of love. Outside, the stars drift slightly. The Earth spins, carrying the telescope eastward, yet the mount moves just enough to cancel that motion. In the sky's grand rotation, one fragile human instrument stays fixed on a single wandering point. It's almost poetic, the balance between movement and stillness, the way our species has learned to hold its gaze steady across the turning of a planet. Midnight passes. More data accumulates. Spectrographs measure colors beyond human sight: infrared, ultraviolet. These tell stories of temperature, composition, perhaps even history. The astronomers take notes, cross-check results, compare with previous nights. Gradually, patterns form. The object's color suggests certain minerals, perhaps frozen volatiles. Its brightness curve hints at rotation, a slow tumble through space. You imagine the light echoing from its rough surface, a place no one has ever seen, yet now held in data, known by reflection. In that moment, the universe feels close enough to touch. Hours later, dawn begins to pale the sky. The telescope shutters close, the data saved. The astronomers stretch, exhausted but fulfilled. They have gathered not just light, but time, a fragment of the universe's ongoing story. You watch with them, feeling the satisfaction of quiet work completed. As they step outside, the air is crisp, and the horizon glows with morning. The stars fade one by one. The interstellar traveler continues its way, unseen for now, but its trace remains in the captured photons, in the minds that studied it, and in you, the quiet observer who, for a while, joined in the silence. The observatory rests again. The world brightens. Somewhere, deep inside, you feel the same stillness linger. You have watched, and through that watching, you have become part of what you observed. You breathe once more, slow and steady. The night's silence settles into memory. The universe continues, vast, calm, infinite, waiting for those who will listen again. And as the last star disappears into daylight, a new question forms softly in your mind. What secrets might the dust itself hold? The telescope's data is now silent in the archives, waiting to be decoded. Within those faint lines of light, hidden inside the spectra, lie clues, patterns that reveal what the interstellar visitor is truly made of. The astronomers begin to analyze, tracing each wavelength, comparing it to known fingerprints of elements and compounds. The process is methodical, deliberate, and filled with quiet anticipation. Every element leaves a signature. Hydrogen sings in one frequency, sodium in another, iron in yet another. These lines are the universe's alphabet, the written language of light. As the scientists examine them, they start to reconstruct the object's hidden chemistry. It is like reading a book whose pages are scattered through space, illuminated one photon at a time. They find something unexpected. The object spectrum does not fully match that of typical solar system comets or asteroids. There are similarities, yes, traces of silicates, some frozen gases, but also subtle deviations. Certain metals appear stronger, others fainter. Ratios differ in ways that tell a deeper story. This material was formed under different conditions, perhaps around another star altogether. It carries, in its dust, the memory of an alien sun. You picture these dust grains, tiny, ancient, irregular. Some no larger than the width of a hair, yet each one a time capsule. They may have condensed in a protoplanetary disk billions of years ago, orbiting a star that long ago dimmed or died. Over time, collisions, radiation, and gravitational tides may have liberated them, casting them into interstellar space. They drifted for eons, silent and dark, until finally they crossed paths with ours. Now, through light alone, we touch them. Each spectral line measured in the lab carries meaning. A shift in wavelength might indicate motion, a faint trace might suggest the presence of nickel or magnesium, a small bump might reveal frozen carbon dioxide or simple organics. The scientists know that such clues are fragile. One missed calibration could distort a signal, so they proceed slowly, checking and rechecking. Their patience is part of the process, a quiet collaboration between curiosity and rigor. The composition reveals not only what the object is made of, but also where it might have come from. High ratios of refractory metals, elements that form at higher temperatures, could mean it was born close to its parent star. A greater abundance of volatiles, like ices and carbon compounds, might hint at a formation farther out. But this visitor defies easy classification. It shows both traces of metals from heat and ices from cold. It is a paradox in motion, a relic from a system that mixed its ingredients differently. You imagine such a system, a young star forming in a nebula, surrounded by a swirling disk of gas and dust. Inside that disk, tiny solids collide and merge, growing into pebbles, boulders, and planetesimals. Some remain, others are ejected by the gravitational pull of giant planets. One of those, perhaps, became this traveler, a small fragment of a much larger cosmic experiment, now journeying across the stars. The astronomers study isotopes too. Ratios of oxygen or carbon isotopes can reveal whether the object's parent star was hotter, older, or richer in heavy elements than our Sun. The results are fascinating. The patterns don't match any solar system body exactly. This is confirmation. The visitor truly comes from beyond. It is interstellar not just by path, but by birth. Within its dust, there may even be pre-solar grains, particles older than any star alive today. Some of these grains, like silicon carbide or graphite, can survive billions of years of cosmic travel. Under a microscope, they would look like jagged crystals, formed in the outflows of dying stars before our Sun existed. To think that such material now drifts through our solar system, it is like receiving a message from the deep past of the galaxy itself. The scientists compare the results to meteorites, comets, and interplanetary dust particles collected by spacecraft. They find echoes, but not exact matches. The metals in this visitor seem less processed, more pristine, as if untouched since its birth. That purity is rare. It offers a glimpse into how different stellar environments forge their worlds. You think about the meaning of that. Everything, planets, rocks, even your body, is built from stardust. But not all stardust is the same. Some was born in the hearts of red giants, some in the violent deaths of supernovae, some in calm clouds that never became stars. Each carries its own isotopic accent, its own chemical history. In the dust of this traveler lies a dialect of the universe we have never heard before. Dust grains are small, but they shape galaxies. They absorb and scatter light, cool clouds so stars can form, and lock up elements that would otherwise remain in gas. Without dust, there would be no planets, no oceans, no living chemistry. And here, in this interstellar object, that same dust whispers across the void, unchanged, uncorrupted, bridging the space between solar systems. In laboratories back on Earth, researchers simulate such conditions. They heat minerals in vacuum chambers, freeze gases, measure spectra under different pressures and temperatures. They compare those artificial signals to what telescopes see. In that way, they reverse engineer cosmic history. Science, at its heart, is patient reconstruction, an attempt to remember what the universe once knew. The findings spread through the community. Papers are written, discussions bloom. Some argue the object is more asteroid-like, others see it as a frozen comet. Both sides find evidence, but neither conclusion feels complete. The truth, it seems, lies somewhere between categories, as if the cosmos reminds us that our definitions are human conveniences, not laws of nature. You find calm in that uncertainty. The universe doesn't need to fit our expectations. It simply is. Its beauty often comes from the exceptions, the irregularities, the things that refuse to be ordinary. The interstellar traveler, with its unusual metals and strange mix of dust, is one of those reminders that diversity is not deviation, but expression. Somewhere in its layers, perhaps buried beneath its surface, are grains that once floated near another star's light. If one could hold a handful of that dust, it would feel ordinary, grey, rough, perhaps metallic. Yet within it lies history beyond measure, the condensation of atoms that once burned inside a supernova, the coalescence of molecules that wandered through a nebula, the cold sleep of matter between stars. You think about that lineage, from star to dust, from dust to planet, from planet to mind. Every grain connects to the next through time and transformation. The same iron that glints inside this alien rock might also shimmer in your blood. The same carbon that built its surface might once have been part of a distant world's atmosphere. Cosmic chemistry is not abstract, it is shared inheritance. As the analysis concludes, astronomers store the data for future comparison. Technology will improve, and someday, perhaps, another interstellar visitor will appear, and its composition will tell us how different, or how similar, its story is. Together, they will map the diversity of planetary systems across the galaxy, using chemistry as the thread that connects them. You close your eyes and picture the dust drifting again through space, slow, steady, unhurried. It has seen more suns than we ever will, yet carries no memory of harm, only record. In its silence, there is knowledge, and in studying it, we become part of that knowledge, fragments of curiosity orbiting within the great dust cloud of the cosmos. The telescope's dome rests in daylight now, but its data endures, spectral lines, metallic whispers, grains of history stored in numbers. Somewhere, across space, the traveler continues, carrying what it always has, the unspoken memory of stars. For most of human history, the solar system seemed like the natural order of things, a familiar design that might repeat across the universe. A bright central star, planets in neat orbits, smaller bodies of rock and ice swirling along predictable paths. When the first exoplanets were discovered, we expected them to resemble what we knew. But they didn't. Many orbited closer, faster, stranger. The idea of what is typical began to dissolve. Now, as astronomers study this interstellar visitor, this small, icy object that has crossed the void between stars, the question returns, what does normal even mean in the architecture of worlds? It is not just curiosity that drives this question, it is humility. Every time we assume our solar system is the standard, the universe gently corrects us. When scientists compared the composition of this visitor to our comets and asteroids, they found both echoes and deviations. Some ratios of carbon and oxygen seemed familiar, others defied pattern. The mixture of metals and ices did not fit neatly into our models of planetary formation. That inconsistency does not frustrate, it fascinates. It is evidence that the processes shaping worlds are far more varied than one blueprint allows. You picture the early solar system, a disk of gas and dust circling a young sun, planets forming in concentric bands, comets at the edges. Now imagine another system forming elsewhere, under a different star, with different temperatures, densities, and gravitational influences. Even small differences in heat or radiation could alter chemistry, changing what freezes, what condenses, what survives. Over billions of years, those small differences amplify, producing worlds unlike any we could have predicted. The interstellar visitor is a messenger of that diversity. Its presence in our skies offers a sample, a fragment of a system that evolved under different rules. It reminds us that planetary formation is not a single story, but a collection of experiments happening everywhere, all the time. The word typical loses its meaning under such a vast lens. Each star builds its own family. Some have giant planets that migrate inward, others have small rocky worlds clustered close, and some may host nothing but debris. Even the way dust and ice distribute themselves can differ drastically. Our solar system is one melody in an orchestra we are only beginning to hear. When astronomers first found hot Jupiters, gas giants orbiting their stars in just a few days, it overturned everything we thought we knew about planetary stability. When they discovered Earth-sized planets around red dwarfs, it challenged our assumptions about habitability. And now, with this object, we see that even the smallest fragments can carry chemical identities that do not belong to our neighborhood. The cosmos is not standardized, it is expressive. You can think of it like a forest. From a distance, all trees look similar, green, upright, living. But step closer, and you see endless variation in shape, bark, scent, and leaf. Each evolved under slightly different conditions of light and soil. The same is true for planetary systems. Each one grows in its own cosmic climate, shaped by the turbulence and chemistry of its birth cloud. This traveler tells us that there are worlds out there whose compositions may make ours seem unusual. Perhaps in another system, comets are rich in carbon dioxide and poor in water. Perhaps silicate dust is replaced by something more exotic, graphite, metallic compounds, or ice mixed with complex organics. Each discovery widens the map of what nature can do. And that variety is not chaos. It is pattern on a grander scale. The laws of physics apply everywhere, but their outcomes depend on local conditions. Gravity, radiation, magnetism, and chemistry, the same ingredients, endlessly rearranged. The universe creates by recombining, not by repeating. Astronomers now use the term population bias to remind themselves how limited our perspective is. We can only study what we can detect, and so far, we have seen only a thin slice of the galaxy's possible systems. When a new type of planet or comet appears, it does not break the rules. It reveals that our sample was too small. This interstellar object helps fill in one of those missing pieces. It carries the chemical accent of another sun, another nursery, another environment. It may even reflect how common certain conditions are in the galaxy. If future visitors show similar properties, we will know that systems like its parent are not rare. If each differs widely, then diversity itself is the rule. Science advances by collecting such exceptions until patterns emerge. It is slow, patient work, connecting spectra, trajectories, and models into a broader picture. Yet behind the data lies something profoundly human, the recognition that our home is one among many. That realization does not make Earth smaller, it makes the universe more alive. You think of how the planets in our system orbit quietly, each in its track. To us, this feels stable, natural. But to a being from another system, it might seem exotic. They might look at our dry inner planets, our distant gas giants, and wonder how such a configuration arose. What we call normal is just what we are used to. To the universe, it is one of countless arrangements. Even within our own system, nothing is uniform. Jupiter radiates more heat than it receives, Venus spins backward, Uranus rolls on its side. Our typical is already full of oddities. The interstellar visitor only extends that lesson outward, reminding us that the familiar is never the final measure. Scientists have begun modeling how such an object could have formed. They simulate disks with varying metallicities, where the ratio of elements heavier than hydrogen and helium changes the building blocks available. In regions with less metal, planets form more slowly or not at all. In metal-rich regions, giant planets grow early, scattering debris outward. Depending on where the visitor originated, its chemistry may hold the imprint of that early chaos. The models suggest possibilities, but the data keep us humble. We once imagined a universe filled with solar systems like ours, small rocky worlds inside, large gaseous ones outside, a belt of debris beyond. But each discovery, from exoplanets to interstellar comets, paints a different picture. The galaxy is an artist that does not copy. It improvises. Its palette includes silicates, organics, metals, and ice, but every stroke is unique. And in that uniqueness lies reassurance. The universe does not need uniformity to be orderly. Its creativity is its balance. From the same physics emerge infinite forms. That principle applies to you as well. You, too, are not a typical version of anything. Your existence is an expression of conditions that can never be exactly repeated. You are your own small world, complete within its orbit. The interstellar object continues on its path, silent but revealing. Each telescope pass, each spectrographic reading, adds a little more understanding, not of itself alone, but of what is possible. It tells us that when we define typical, we really mean familiar. And that familiarity is not the measure of truth, only of perspective. In time, more visitors will come. Some may look like comets, some like asteroids, others like something in between. Each will tell a different story. Together, they will show that the diversity of planetary systems mirrors the diversity of stars, and that both are shaped by an ancient cosmic restlessness, the drive to create variation from simplicity. As you think about that, your mind settles into the rhythm of acceptance. The unknown is not a threat, it is the space where knowledge grows. The more we learn, the more the boundaries of normal expand, until the whole universe fits inside them. The next chapter of this exploration is already forming, one that looks back to the beginning, to the small icy bodies that carry the ingredients for planets and life. The interstellar traveler, with its mix of metals and dust, hints at their story too. And as it drifts away, you sense the question lingering, quiet but steady. How do comets and planetesimals, these tiny architects of worlds, shape the grand design of everything that follows? Long before planets were born, the building blocks of worlds were already drifting through the darkness, icy, rocky fragments called planetesimals. These small bodies, ranging from meters to hundreds of kilometers across, were the architects of everything larger. Comets are their surviving cousins, the icy remnants of an age when the solar system was still assembling itself. To understand how a solar system grows, we must begin with them. A planetesimal is a story frozen in motion. It forms when dust grains inside a protoplanetary disk begin to collide, stick, and cluster under weak electrical and gravitational forces. Over millions of years, these clusters grow dense enough to pull in more matter. Most merge into planets or are consumed by them. But some escape, exiled to the outer regions or flung into interstellar space. The ones that survive hold records older than any planet's crust, records of the first chemistry that took place in the cold. Comets are among the best preserved of these relics. Their ices protect molecules that date back to the dawn of the solar system. When a comet approaches a star and its surface begins to vaporize, it releases those molecules into space, a plume of information, a chemical memory. Each time we study a comet, we see not just a small frozen rock, but a preserved page from the universe's first chapter of creation. In the early days of our own solar system, comets and planetesimals played multiple roles. They acted as builders, delivering material that merged into planets. They were also couriers, bringing volatile compounds, water, ammonia, and organics, to the inner worlds where it was too hot for such elements to form locally. Some theories suggest that Earth's oceans and even the molecules that became life arrived this way, carried by icy messengers from the outer disk. If so, then our planet's story began with collisions, not creation in isolation. You can imagine it, billions of years ago, a young sun surrounded by swirling dust and ice. Within that glowing mist, tiny fragments collide and grow, forming clusters that spin and merge. Occasionally, gravity pulls them toward each other violently, shattering them back into smaller pieces. The process is not smooth, it is chaotic, self-correcting, and full of failed beginnings. Yet slowly, larger bodies emerge, each a miniature world in formation. Among those, countless never reach planetary size. They remain drifting between the giants, in belts and clouds. Some settle in stable regions, the Kuiper belt beyond Neptune, the Oort cloud far farther still. Others are nudged by gravitational encounters, sent inward or outward, occasionally escaping entirely. The object that recently passed through our solar system, the interstellar visitor, may be one such exile, a planetesimal thrown from another star's nursery. When scientists analyze comets, they see familiar fingerprints, silicates, carbon-rich compounds, simple organics, and water ice. But they also find surprises, molecules that form only under specific temperature or radiation conditions. Each variation tells us something about where and how the comet was born. In that sense, comets are messengers of location, encoding the chemistry of their birthplace in their ice. Planetesimals also reveal how planetary systems organize themselves. The distribution of their orbits shows where material accumulated, how the gravitational influence of forming planets sculpted space. Jupiter, for example, is thought to have shaped the asteroid belt, preventing the rocks there from merging into another planet. Its gravity stirred up the disk, scattering smaller bodies outward. Some of those became the comets we see today. The giants were architects of chaos, their growth both constructive and disruptive. Over time, collisions among planetesimals created the raw diversity of planetary surfaces we now observe. The iron cores of terrestrial planets likely began as accumulations of metal-rich planetesimals. The mantles formed from silicate material that melted under pressure. Every mountain, ocean, and atmosphere traces back to their mergers. The entire architecture of the solar system is written in their movements. The role of comets extends beyond construction. They are also the carriers of transformation. Each time one approaches a star, it sheds part of itself, releasing dust and gas that enrich surrounding space. Over billions of years, such emissions seed interplanetary and even interstellar regions with complex molecules. In this way, comets help spread the ingredients of chemistry across cosmic distances. What they lose becomes the starting material for something new elsewhere. The interstellar visitor observed recently continues that legacy. It is not just a wanderer, it is part of the galaxy's recycling system. When stars form, their disks eject debris. Some of it escapes the gravity of its home star and travels indefinitely through the void. Occasionally, one such body drifts close to another system, passing briefly through before moving on again. Each passage spreads a small sample of matter across the galaxy, allowing different regions to share their chemistry. In this sense, comets and planetesimals are the veins through which the Milky Way circulates material, slow, silent, and persistent. Astronomers have begun to realize that planetary formation is inseparable from planetary exchange. The discovery of interstellar comets confirms that matter does not remain confined to its birthplace. Over cosmic timescales, the boundaries between systems blur. One star's debris becomes another's seed. The universe does not build in isolation, it weaves. Even within our own solar system, comets act as connectors between distant regions. When they approach the Sun, they release fine dust that becomes meteor showers on Earth. Every streak of light you see in the night sky is a small reminder that the planet is still interacting with remnants of its past. The dust burning in our atmosphere tonight may have been frozen in space for billions of years, waiting for this brief return to light. There is something poetic in their impermanence. Comets dissolve with each orbit, yet their loss sustains the cosmic cycle. Without them, planetary systems would lack both diversity and continuity. Their collisions seeded new surfaces, their evaporation spreads organic molecules, their trajectories tell us how stars shape space. They are at once fragile and fundamental, proof that the smallest things can have the largest consequences. The study of planetesimals also provides insight into how rare or common life-bearing systems might be. If comets carry organic molecules widely through the galaxy, then the ingredients for life are not limited to one world. Each new detection of complex carbon compounds in a comet's tail supports the idea that biology's chemistry begins long before biology itself. Life, in some form, may simply be the natural continuation of the chemistry that comets have been conducting for eons. Still, mysteries remain. How exactly do planetesimals grow from dust grains when collisions at small scales should destroy them? How do they overcome fragmentation and gas drag? Computer models struggle with this question, the so-called meter-size barrier. Perhaps magnetic forces, turbulent eddies, or even electrostatic charge play roles we do not yet fully understand. The simplicity of a comet hides the complexity of its origin. In the future, missions may visit interstellar objects directly, collecting samples from beyond our solar system. Each fragment will tell us more about how stars and planets exchange material, and perhaps how the same chemical threads have woven through the galaxy for billions of years. To study comets and planetesimals is to trace the roots of cosmic kinship. Even now, telescopes scanning the sky watch for new arrivals. Each detection begins a familiar sequence: orbital analysis, brightness tracking, spectral decoding. Yet behind the calculations lies wonder. These objects are not intruders but emissaries. They remind us that the boundaries between systems are thin, and that the dust of one world may someday seed another. The role of comets and planetesimals, then, is not minor. They are the first builders and the last witnesses, the matter that connects origins to outcomes. Every planet owes its existence to their restless collisions. Every star system, no matter how alien, begins with their dust. The story of worlds is the story of these fragments learning, over immense time, how to hold together. As you imagine them drifting silently beyond Neptune, glowing faintly in reflected sunlight, you can almost sense their patience. They do not hurry. Their orbits may take millions of years, but the universe waits with them. Each time one returns, it carries the memory of creation, and perhaps, the faint promise of beginnings still to come. There is a moment, when the telescope's light fades and the data stops arriving, that silence takes over. You are left not with answers, but with a widening sense of awe. The interstellar visitor drifts farther away, and yet, your mind follows it, past the reach of instruments, into a region where knowledge becomes imagination. What remains is longing, not for possession, but for understanding. Longing, in science, is not weakness. It is the quiet gravity that keeps us looking up. Each question about this wanderer, where it came from, what it's made of, what it means, draws from that same impulse. Wonder is the human response to scale. The cosmos humbles us not because it ignores us, but because it continues without us, in its vast, unhurried rhythm. To stand beneath such immensity and still feel curiosity is an act of both courage and surrender. Astronomers speak of data and error bars, of trajectories and reflectance spectra. Yet behind their precision is a deep emotional core, the awareness that even our most advanced instruments touch only a sliver of the universe's truth. The rest lies beyond, like a horizon you can never reach. That unreachable horizon is what gives science its soul. The more we learn, the larger the unknown becomes. Knowledge expands, and with it, humility. When you think of the interstellar object, the frozen traveler that slipped through our solar system unannounced, you might picture it as a symbol of distance. But in another sense, it is intimacy embodied. It came from somewhere else, carrying fragments of another story. It reminds us that every atom in your body once traveled too, through stars, through explosions, through eons of cosmic drift. You are made of material just as ancient and unclaimed as that object. The difference between you and it is only organization, not origin. As the visitor fades into darkness, scientists continue to discuss its mysteries, its shape, its color, its unusual motion. Some say it was a comet, others, an asteroid. A few even propose it was something entirely new. The truth remains uncertain. But perhaps uncertainty is part of the beauty. Mystery preserves wonder. When everything becomes known, curiosity falls silent. So we linger here, between comprehension and reverence. There is humility in realizing how small our place is, not in the sense of despair, but in perspective. The sun, the planets, and all of humanity form one tiny corner of a single galaxy among billions. Yet the laws that shape that galaxy, gravity, electromagnetism, atomic structure, are the same laws that operate within your body. The rhythm of your heartbeat follows the same physics that governs orbital motion. To be humble before the universe is also to recognize that you are inseparable from it. When ancient people looked at comets, they saw omens or messengers from the gods. Today, we see icy relics of formation. Yet the feeling is not so different. The sight of a luminous tail stretching across the night sky still stirs something older than language. That impulse, to look, to wonder, to imagine meaning, is universal. Whether we express it through myth or mathematics, it connects us to the same source, the desire to belong in a universe too vast to grasp. There's a quiet beauty in knowing that we cannot control the cosmos. The interstellar traveler will not alter its course because we observe it. It moves according to forces indifferent to our attention. And yet, our act of observing transforms us. By watching, by caring, we become part of the story. The cosmos remains silent, but through our curiosity, we give it a voice. Imagine standing beneath a clear night sky, the air still, the stars unwavering. Somewhere out there, the object continues its path, a faint, cooling ember receding into darkness. You know it will never return, never pass this way again. And still, you feel a strange kinship. For you, too, are passing through a brief moment in cosmic time. You, too, are transient. To feel wonder in that transience is to live fully within it. In moments like these, the difference between science and spirituality softens. Both arise from the same realization, that existence is larger than comprehension. To study the universe is not to diminish its mystery but to deepen our relationship with it. Each discovery reveals how finely tuned and interconnected everything is. The humility it inspires is not defeat, it is gratitude, for being able to witness even a fragment of the infinite. Longing, wonder, humility, these are not emotions to be overcome, but companions to knowledge. They keep us gentle with our questions. They remind us that discovery is not conquest but communion. The universe does not yield itself easily, but it does allow glimpses, and those glimpses are enough to sustain curiosity across generations. As you reflect on the interstellar wanderer, let yourself rest in that gentle not knowing. You do not have to solve it. You do not have to reach its end. The questions are enough. The act of asking them, softly and sincerely, places you in harmony with the cosmos. Just as comets trace long arcs around the sun, your thoughts, too, can orbit mysteries without needing to capture them. Now, as the night deepens, let that awareness settle. Your breath slows. The stars remain constant, their light crossing years to reach your eyes. Somewhere beyond them, the visitor fades into interstellar night, carrying with it the echoes of every gaze that followed it. You exhale, and the air leaving your lungs becomes part of the same ancient cycle. You are not separate. You are part of the long, slow wonder of it all. There comes a point in every orbit where closeness and departure are one and the same. The interstellar traveler approaches perihelion, the nearest point to the sun, and in that closeness, it finds both warmth and release. You imagine it now, gliding through the inner solar system, sunlight spilling over its surface. Ices tremble, gas begins to flow, and what was once frozen for billions of years begins to breathe again. The sun greets it not as a master, but as a host. Golden photons, each traveling for 8 minutes from the star's blazing surface, now meet the cold, dark contours of an object older than our world. The heat penetrates the outer layers, turning solid ices to vapor, carving faint channels through the surface dust. The visitor shimmers faintly, not in sound or color, but in transformation. What was once locked away is now set free. This moment, this solar embrace, is both intimate and indifferent. The sun does not know it is warming an interstellar guest. It simply radiates, endlessly generous. And the object, in turn, accepts what it must, shedding its surface like breath in winter air. You think of your own life, how proximity to light can change you, how warmth can draw out parts of yourself long hidden beneath layers of cold and distance. Scientists on Earth observe this stage with fascination. As the visitor brightens, telescopes capture the reflected sunlight, not just beauty, but information. Spectra reveal gases, temperatures, densities. Each photon carries a message, decoded through instruments and equations. From afar, humanity witnesses a brief communion between a star and a wanderer from the dark. It is a moment of contact measured in chemistry and motion, but also in quiet emotion. The interstellar traveler, once nameless in deep space, now finds itself surrounded by the machinery of curiosity. Arrays of radio dishes turn toward it. Observatories in Chile, Hawaii, and orbit align their gaze. For a few weeks or months, it becomes a central figure in the great story of observation. Yet it does not linger. Its velocity, immense and unstoppable, ensures that soon it will slip away again, out of reach, out of sight, into the silence from which it came. You can imagine that moment of departure. The object swings around the sun, its path curved by gravity but never captured. It is too fast, too free. The sun's pull bends it, but cannot hold it. After its closest approach, it begins the long outward arc, back toward the outer reaches of the solar system, then beyond, into interstellar space once more. The warmth fades, the gases settle, and the faint tail it grew begins to disappear. In its leaving, there is no sadness. Only the natural rhythm of orbits and motion, attraction and release. The sun's embrace was temporary by design. So is every act of contact in the universe. Stars pull, objects respond, and then they part. The same pattern governs your breath, your relationships, your moments of awakening and rest. You, too, are always moving between gravity and freedom, between warmth and the long calm beyond it. Astronomers calculate its future trajectory, tracing its path through the constellations. They project where it will be in a year, in a decade, perhaps never to be seen again. They know its speed, faster than the escape velocity of the solar system. Once gone, it will not return. It will continue drifting between stars, a survivor of another system's birth, carrying traces of light from ours, perhaps a few atoms of solar wind, a dusting of interplanetary particles. A brief exchange between two worlds, carried onward into the dark. It's easy to feel a touch of melancholy at this. The visitor came unannounced, revealed a fragment of its mystery, and then left. But the story it tells is one of continuity, not loss. In leaving, it reminds us that all things move through cycles: approach, transformation, departure. Even the sun, in its brilliance, will one day fade, its outer layers cast off into the cosmos, to become material for new stars, new worlds, new travelers. The universe, at every scale, is built on this rhythm. In the warmth of the sun, the traveler's ices release gases: water, carbon monoxide, methane. These molecules, simple yet ancient, drift outward into the solar wind, merging with the flow of particles streaming from the star. For a short while, part of the object becomes part of the sun's breath. It's a poetic exchange. Light becomes heat, heat becomes gas, gas becomes motion. Every transformation connects to the next. You breathe in slowly, and you realize you are doing the same. You take in warmth, light, oxygen, the gifts of cosmic processes billions of years in the making. The atoms in your breath were once in the hearts of stars, in the atmospheres of worlds, perhaps even in passing comets. To exist is to exchange. Nothing truly leaves the universe, it simply changes form, following paths beyond comprehension. The interstellar traveler, now past its moment of brilliance, begins to fade. The coma that once surrounded it dissipates. Its tail thins into invisibility. Astronomers continue to track it for as long as they can, collecting the last photons before it disappears from detection. The numbers on their screens grow smaller, then vanish into noise. And somewhere in that silence, the object continues, steady, unhurried, carrying the memory of our sun as a faint warmth in its frozen body. As night falls on Earth, you imagine it still, a small glint receding into infinite darkness. The sun remains behind, unchanged, glowing as it has for billions of years. The visitor leaves with a story written not in words, but in orbit and evaporation, in light absorbed and reflected. It was never meant to stay, and that is what makes its passage beautiful. Its brief visit revealed truths about our own home. That warmth is fleeting, but meaningful. That connection need not last to be real. You close your eyes and feel your own orbit, around your thoughts, your emotions, your memories. Like the traveler, you move close to warmth, to moments of illumination, and then drift back into rest. There is no need to hold the light forever. It is enough to have felt it. Somewhere beyond the reach of any telescope, the interstellar wanderer continues into the quiet beyond. It carries traces of our sun's heat, the attention of our scientists, and the curiosity of every human mind that wondered about its path. You breathe deeply, and in that breath, you sense your kinship with it, both of you travelers through time and space, warmed by light, set free again to drift. And as you drift too, gently, towards sleep, you sense that the sun's embrace was never an ending. It was a beginning of another phase, a journey outward, into the unknown, into the calm that follows illumination. When the visitor has gone and the instruments have cooled, the data remains. Lines on graphs, points in space, faint signals in the noise, these are what the scientists keep. They gather in quiet rooms, coffee in hand, faces lit by monitors, and they try to piece together what the universe has whispered. It is not everything. It is never everything. But it is something, and that something expands the horizon of what we know. From the light it reflected, we learned composition. From its speed, we learned freedom. From its path, we learned that it came from beyond, carrying traces of another star's nursery. Carbon dioxide stronger than water. Dust particles shaped by unknown conditions. Ratios of isotopes that do not match our own. Each clue is a fragment of a distant history, and when assembled, they form a quiet revelation. Not all planetary systems are like ours. You picture the astronomers working through nights, their telescopes pointed to where the visitor once was. They are studying absence now, what has faded, what can only be inferred. It is a humbling practice, to study what is no longer there. You feel that same humility in yourself sometimes, tracing memories that have passed, trying to understand what remains of them. Science and reflection share that silence. Our models improve with every visitor like this. Equations once thought solid bend gently under new evidence. Theories of how stars form planets, how disks of dust evolve into worlds, are all tested against these travelers. You imagine the early solar nebula, a swirl of gas, dust, and ice. Some fragments stayed, coalescing into planets. Others were cast out, ejected into interstellar space. The visitor may be one of those fragments, a relic of another star's beginnings, wandering through time until chance brought it here. And yet, for all we learn, the mysteries grow deeper. What star did it come from? How long has it traveled? Was it born of violence, a collision, a gravitational slingshot, a stellar migration? These are questions that hang unanswered in the air, like faint echoes after a song. The more we know, the clearer it becomes that knowledge itself has edges, and those edges dissolve into wonder. You reflect on how that feels. Each discovery widens understanding, but also reveals the vastness still uncharted. Scientists call it the frontier of the unknown. You might call it the space of curiosity. It is the quiet awareness that there will always be something just beyond reach, a truth both humbling and serene. The universe will never run out of mysteries. That, in itself, is a form of comfort. In the data, we see the chemistry of ancient ice, the reflections of alien dust, the faint signs of sunlight bouncing off a surface we will never touch. These things tell us about formation, about age, about movement. But what they do not tell us is what it means, not just in scientific terms, but in the way meaning lives in your thoughts at night. What does it mean that material from another star now drifts through ours? What does it mean that two systems, separated by light years, can meet, however briefly? Perhaps it means that separation is never absolute. Space is vast, yes, but it is also a web of motion and interaction. Every so often, paths cross. Comets fall. Dust meets dust. And we, here on this small world, are part of that network, connected by gravity, by light, by the simple fact of existing in the same cosmos. What we learn, then, is not only about the object itself, but about ourselves, our capacity to seek, to wonder, to find beauty in impermanence. Still, many details remain out of reach. The instruments have limits, and so do we. Light fades with distance, signals weaken, and interpretations carry uncertainty. The error bars are wide, the margins uncertain. Yet within those uncertainties, progress unfolds. Science, like the traveler, moves steadily forward, guided not by perfection but by curiosity. Every question answered creates two more, each smaller, sharper, more intricate than before. You think of your own life again. How every time you understand something, a feeling, a memory, a person, the understanding opens new questions. The unknown is not a void to fear, it is the background that gives meaning to the known. The scientists, with their graphs and spectra, live in that same balance. They do not despair over mystery. They rely on it. Without it, discovery would end. The visitor has taught us that the universe makes wanderers more often than we imagined. The gaps between stars are not empty, they are full of travelers, silent and ancient. Some might pass near other systems, unseen. Some might bear signatures of chemistry unlike anything in our experience. To think of them is to realize that the cosmos is not a set of isolated islands, but a sea of stories crossing paths. And we, standing on our small shore, are listening. As we refine our models, we begin to look outward differently. We search for patterns that might reveal where such objects come from. We scan nearby stellar associations, regions where stars are born together. Perhaps our visitor was ejected from one of these young systems billions of years ago. Perhaps it has been drifting ever since, through radiation, dust, and time. To follow such a story is to trace the lifeline of a single grain of cosmic history through epochs beyond imagining. Even now, computers hum quietly in observatories and universities. Simulations run, tracing orbital possibilities. Spectral data is compared with known samples. Tiny adjustments in numbers can change entire interpretations. The scientists know they are painting with limited colors, but they continue, not out of certainty, but out of devotion to truth. They know that in every pixel of starlight, the universe is telling a story. You take a slow breath. The rhythm of science, question, test, revise, wonder, feels familiar. It mirrors the rhythm of thought, of life. The visitor has left, but the curiosity it sparked remains. In that sense, it is not gone. Its trajectory cuts through our collective imagination, a reminder that even brief encounters can shift understanding in lasting ways. What we learn is measured. What we don't is infinite. Between the two lies a space of reflection, the human mind, always reaching, never satisfied, yet at peace in the act of reaching. The scientists continue their work, and so do you, in your own quiet way, pondering how little we know and how much that little means. Outside, the night sky remains unchanged, its stars steady. But you know now that in that darkness, unseen objects drift, remnants of other worlds, silent teachers. You close your eyes and see them moving, slowly, gracefully, each carrying secrets that will outlast generations. And as your thoughts begin to slow, you feel a soft realization. Maybe not knowing everything is what keeps the cosmos alive in our hearts. The unanswered questions give shape to wonder itself. There is a moment, sometimes late at night, when the distance between you and the universe disappears. You step outside, the air cool, the sky scattered with stars. You lift your eyes, and the act feels both ancient and intimate. You are not simply observing the cosmos, you are participating in it. The photons touching your eyes began their journey long before you were born. They have crossed the void to find you, carrying silent messages from worlds beyond sight. In that exchange of light, you and the cosmos are joined. The scientists measure this connection in data, but you feel it as stillness. The telescope extends vision, the heart extends wonder. Somewhere, in the intersection of those two, communion happens. A dialogue without words, spoken in the shared language of existence. You are made of matter that once burned in the cores of stars, yet you can contemplate those same stars with consciousness. The symmetry of that truth is breathtaking. The universe studies itself through you. As you stand there, breathing softly, you imagine the atoms in your lungs, oxygen born in a red giant, carbon from a long-dead sun. Every inhalation is a quiet remembrance of stellar death and rebirth. Every exhalation returns that story to the air. Life, you realize, is not something separate from the cosmos. It is a continuation of it, a rhythm echoed across scales. The stars expand and collapse, and so do you, in your own way, through thought and rest, curiosity and silence. Far above, planets circle unseen suns. Comets glide between them. Dust drifts in faint ribbons of light. The visitor you once followed is now far beyond reach, a small wanderer swallowed again by the dark. But its journey still resonates within you. It taught you that nothing in the universe is ever truly alone, not even a rock of frozen carbon passing between stars. Every object, every particle, exists in relation, pulled gently by gravity, influenced by light. You too are held in that vast web of connection. You recall how scientists once spoke of the cosmic web, a structure stretching across billions of light-years, galaxies linked by threads of dark matter. You imagine that pattern now, a lacework of glowing filaments, galaxies like pearls strung on invisible strings. Somewhere, on one of those pearls, you stand, thinking about the whole. And somehow, that thought itself becomes part of the structure, a filament of awareness running through the infinite. In that awareness, solitude fades. The loneliness that sometimes comes when staring into the immensity of space softens into belonging. The universe does not watch you, nor does it need to, but you, by existing, give it eyes, give it meaning. The stars burn whether or not you see them, but seeing them changes everything. It turns distance into intimacy, silence into dialogue. The act of wonder itself is the bridge. You picture the scientists again, sitting at their instruments, their screens filled with graphs and spectra. They too are participants in this quiet communion. Each line they plot is an echo of the same question that you feel now in your chest. What are we part of? The tools differ, the language differs, but the essence is the same. Every discovery, every spectrum, every image, is another attempt to listen more clearly to the universe's hum. And that hum, you think, is always there, beneath everything. In the pulse of your heart. In the slow spin of Earth. In the faint radiation left over from the birth of all things. The cosmos is not something outside of you. It is the field in which you live, breathe, think, and dream. When you close your eyes, the darkness you see behind your eyelids is made of the same silence that fills interstellar space. You are not looking at the universe, you are looking through it, from within. Perhaps communion with the cosmos is not about knowing more, but about feeling deeply. To sense connection not as metaphor, but as fact. To know that the hydrogen in your body once shimmered in the first stars, that your thoughts are powered by fusion's ancient light. To realize that your consciousness, fragile, fleeting, human, is a continuation of cosmic evolution, a ripple in the same ocean that gave birth to galaxies. You breathe again. The air is cool. Somewhere, a star dies. Somewhere else, a star is born. The same processes that shape the heavens shape you. And in that balance between vastness and intimacy, you find peace. There is no need to solve the universe tonight. To simply be aware of it, and of your place within it, is enough. The visitor, the scientists, the data, the light, all of it has led here, to this moment of reflection. You realize that the boundary between science and wonder is softer than it seems. The equations describe what happens. The ore describes why it matters. The visitor's path across our sky may be gone, but its meaning endures, carried in our curiosity, in our willingness to look up. And maybe that is what the cosmos asks of us. Not worship, not fear, but attention. A quiet listening. A readiness to be amazed. In the stillness of your gaze, the stars seem to shimmer more brightly, as if acknowledging that shared awareness. It is not communication in any literal sense, but it feels real enough. You and the universe, each reflecting the other's existence. You let your mind drift, as though floating through space. You imagine leaving Earth, rising above the thin blue line of atmosphere, past the orbit of the Moon, beyond Mars, beyond the glow of the Sun. The farther you go, the quieter it becomes. And yet, that quiet is not emptiness, it is fullness, depth beyond words. You understand, then, why astronomers speak of or not as an emotion but as an experience that changes you. To feel small and infinite at once is to be truly awake. The communion is wordless, but it leaves an imprint. When you return, when you open your eyes to the familiar, you carry a new stillness inside you. The traffic, the noise, the rush of life all seems softer, gentler, as if part of a larger harmony. You realize that the same laws that shape galaxies shape the curve of a leaf, the rhythm of a heartbeat, the orbit of thoughts within your mind. And so, you continue the dialogue, not through words, but through attention. Every time you look up, you are answering a call billions of years old. Every time you wonder, you add your voice to the chorus of consciousness that the universe itself has created. The stars will continue to burn. The visitors will continue to pass. And you, standing in their light, will continue to listen. The night sky feels softer now. You imagine lying beneath it, the air still, the stars beginning to shimmer through the fading blue. Above you, the interstellar visitor has already begun its long return. The tail that once gleamed faintly in reflected sunlight now dissolves into the quiet dark. It drifts farther, its dust thinning into nothing, its path widening into the eternal distance between stars. You let your breathing follow it, slow, rhythmic, effortless. Every molecule in your body was once free like that, floating in the dark before the sun was born. Hydrogen atoms, carbon fragments, oxygen, all once traveled unanchored through the vast interstellar medium. Now, they rest inside you. As the object leaves, it reminds you that even stillness is motion seen from another frame. You are moving with Earth, Earth is moving with the sun, and the sun itself sails around the galactic center. Nothing is truly at rest, and yet you feel completely still. The stars above form patient patterns, each a slow-moving flame. Some of them are gone already, their light just now reaching you. Others are still growing, bright with fusion. They surround you like distant campfires, each one a story burning across time. The interstellar visitor came from one of them, or from a planet circling one, long ago disrupted and flung outward by gravity's quiet violence. It carries, in its atoms, the fingerprint of another sun. You picture that distant home, a small, red star perhaps, or a young, bright one surrounded by dust and promise. As you imagine this, you begin to sense the scale of time expanding in your mind. Millions of years pass like the slow closing of your eyelids. The journey that brought this object to us is almost impossible to fathom. The distances, the centuries, the waiting. And yet it happened. Somewhere, long before human eyes evolved to see, a star system ejected a frozen fragment. It wandered, unlit and untouched, until it met our sun. You breathe in that story, a story of motion, patience, and quiet inevitability. Astronomers have watched it fade. Their telescopes no longer capture a bright core or measurable tail. It becomes a dim point among thousands of others, almost indistinguishable. But even as it vanishes, the data remains, light curves, spectra, orbital plots. They form a record, a kind of memory of its passing. You imagine scientists at their desks, tracing the faint signal, measuring how sunlight scattered off its surface. Each observation adds another whisper to the collective understanding of our cosmic neighborhood. You think about how much of science depends on faintness, on seeing the nearly invisible and turning it into meaning. The interstellar object, barely a speck, tells stories about planetary systems we will never visit. Just as your smallest memories, almost forgotten, shape who you are. The faintest signals matter. The softest traces endure. The visitor continues outward, accelerating slowly under the sun's fading pull. Beyond the orbit of Neptune, beyond the Kuiper belt, it passes into the realm of the Oort cloud, where icy bodies drift like frozen seeds around our star. Here, it becomes one of them for a while, indistinguishable from the local wanderers. And then, one day, even the sun's gravity lets go. It joins the interstellar stream again, a particle of memory moving through the galaxy's quiet current. You wonder what it feels like to drift between stars. There is no up or down, no light except the distant scatter of galaxies. Space itself hums faintly with background radiation, the afterglow of the Big Bang. It is not silence, but something softer, a whisper from the beginning of time. The object will glide through that sound, carrying traces of our solar system now, a few atoms of hydrogen stuck to its surface, a fingerprint of solar dust. It came as a stranger, and it leaves with souvenirs. The thought comforts you. Exchange happens everywhere, even across light years. A comet from another star leaves dust in our sky. Our atmosphere sheds particles that drift into the void. The boundary between systems, like the boundary between breaths, is more porous than it seems. You exhale, and somewhere, atoms that were once inside you will travel beyond this planet. Motion is life's quiet promise. As the visitor fades from human sight, you imagine yourself watching through the eyes of a telescope one last time. The star field shifts. The faint dot becomes part of the background. There is no dramatic ending, just a slow merging into the general night. The universe doesn't close its stories abruptly. It lets them dissolve gently, leaving space for the next beginning. You feel your own edges blur in sympathy. The lines of your thoughts soften. Your mind becomes like an open sky where one idea fades into another. The interstellar object becomes a metaphor for every question that once visited your mind, arriving from unknown places, staying long enough to change something within you, and then drifting away quietly. The important part was never the duration of its visit, but the awareness it brought, that you are part of a living, moving universe. You think again of gravity, not just as a force that binds, but as a rhythm. Every orbit, every curve, every fall is a kind of dance step in the choreography of existence. Even departure is a form of participation. The comet's escape is simply another motion in the endless pattern of return and release. It mirrors how you let thoughts come and go, how you let sleep approach, not by chasing it, but by allowing it. Your body feels heavier now, but not with weight, with presence. Your breathing deepens into a quiet equilibrium. Each inhale feels like gathering starlight, each exhale like letting go of it. You become aware of your pulse, a quiet, internal orbit echoing the motion of planets. Inside you, atoms continue their vibrations, their collisions, their tiny rotations. Even in rest, you are never motionless. Somewhere, far beyond what eyes can see, the visitor continues its unending flight. It passes through regions where the interstellar medium is sparse and thin, just a few atoms per cubic centimeter. Occasionally, it encounters a faint dust grain, or a cosmic ray, or the electromagnetic whisper of a distant pulsar. Each encounter changes it imperceptibly, adding microscopic scratches to its surface, shifting its rotation by an almost invisible degree. Over millions of years, these tiny changes accumulate. The universe does not rush, it works in centuries and patience. Eventually, in some far future, another civilization may see it, perhaps around another star, perhaps from another world. They may wonder, as we did, about its origin. They may call it their own interstellar visitor, unaware that once, long ago, it passed by our small blue planet and was watched by beings who dreamed under starlight. The object will carry no memory, no message, just the quiet testimony of persistence. That, too, is a kind of communication. You let that thought settle. It feels gentle, like the last trace of twilight before full night. The journey continues without you needing to hold it. You release it, the way the sun released it. The way your mind releases thoughts as sleep approaches. The object drifts on, you drift inward. Soon, there is only darkness and breath. The stars above seem to expand into infinite stillness. You close your eyes, knowing the universe is not stopping, only moving slowly enough for you to rest. And as your thoughts dissolve, one remains. Everything that drifts is still part of everything else. The visitor moves outward, and you follow it, softly, into the calm beyond motion. The night fades slowly, as if the universe itself is taking a long, deep breath. You sense it before you open your eyes, the subtle lightening of space, the change in the tone of silence. Somewhere beyond the horizon, the sun prepares to rise. Its light, still hidden from your sight, touches the upper layers of the atmosphere, scattering through molecules that once floated freely in the dark between stars. The morning begins not as a single moment, but as a slow emergence, a reminder that every ending, even the quietest, folds gently into beginning. You are still, wrapped in that moment between sleep and wakefulness. The memory of the interstellar visitor lingers, like the faint afterglow of a dream. It has drifted far now, invisible to any telescope, moving deeper into the galactic night. Yet its passing has changed you. You have watched it enter, curve near our sun, and fade away. In that journey, you saw reflected the pattern of all existence: arrival, encounter, departure, continuation. Every orbit, every life, every thought follows that same rhythm. The sunlight strengthens. It crosses the distance of space in 8 minutes, a cosmic heartbeat, before brushing your face with warmth. This light is older than human history. It has fueled every tree, every ocean current, every motion of life on Earth. And even as it nurtures your world, it continues its own endless travel outward, scattering photons into the dark. The sun gives and gives, never holding anything back. Its radiance is an act of continual letting go. You think of how the visitor once felt that same warmth, how, as it neared perihelion, ice turned to vapor, gas to light. The sunlight uncovered what lay hidden beneath the surface, just as new understanding often emerges when curiosity meets illumination. The object's glow was never its own. It was borrowed sunlight reflected back. In a way, that is what life does, too. You absorb light, in your eyes, in your cells, in your thoughts, and you reflect it outward in the form of awareness. Every sunrise is an experiment in renewal. You inhale the air, oxygen released by ancient forests, nitrogen shaped by supernovae, carbon that once danced in the atmosphere of long-lost worlds. The atoms that sustain you were not made here. They were built in stars, ejected through explosions, cooled in clouds, and gathered into planets. Morning is not merely the turning of the Earth. It is the reawakening of cosmic matter into consciousness. You feel a quiet gratitude for that connection. To know that you are made of the same ingredients as distant comets, nebulae, and stars, it turns existence into something personal. The universe is no longer just a vast place of cold distances. It is a shared origin story. Every particle in you has traveled, collided, transformed, and been reborn. You are both the observer and the evidence, a living record of stellar evolution. Outside, the light grows stronger. It touches the edges of leaves, the quiet roofs, the stillness of the morning air. The world looks the same, and yet it feels different because you are seeing it with the memory of the cosmos still in your mind. The patterns of the interstellar visitor's orbit echo in everything around you. The turning of the Earth, the fall of rain, the slow movement of clouds. Gravity, that silent sculptor, is everywhere at work, shaping both the paths of comets and the rhythm of your own body. You recall how astronomers once waited through long nights to capture the visitor's faint light. Their instruments gathered photons one by one, adding them up until a shape emerged. You realize that understanding works like that, too, a gradual accumulation of small insights until clarity forms. The scientists never touched the object, yet through its light, they learned something about the architecture of the solar system, about how planets form, about how rare and precious encounters can be. Knowledge, like light, travels slowly but faithfully. The visitor taught us humility. It reminded us that our solar system is not isolated, not special in its design. Somewhere out there, other stars are surrounded by debris, by worlds, by wanderers. There are countless solar systems, each with its own chemistry, its own music of motion. The one you inhabit is just one variation in an infinite theme. Realizing this is not to diminish your place, but to broaden it. You belong not to a single world, but to the universe that gave rise to them all. The sun climbs higher. Its warmth seeps into the air, into your skin. You feel the slow awakening of your body, the quiet chemistry of morning. Your heart beats with renewed steadiness, echoing the rhythm of orbits. Your breath deepens, drawing in air that has circled the planet countless times. Even the wind carries a trace of cosmic continuity, a movement of atoms that once belonged to ancient seas and drifting clouds of dust. You let yourself imagine the visitor again, now almost lost among the stars. It carries traces of us, perhaps a microscopic particle from the solar system clinging to its surface, a faint signature of sunlight stored in its ice. Someday, far from here, it will cross into another region of space, another system. Maybe there, another observer will see it and wonder. The cycle will begin again: discovery, study, reflection, and the soft astonishment that accompanies every glimpse of connection. In that thought lies the essence of morning's promise: continuity. Nothing truly ends. It transforms. Night turns into day, silence into sound, stillness into motion. Even decay gives rise to new creation. The carbon released by a dying star becomes the seed of life in another. You, too, participate in that endless recycling. Your breath feeds the air. Your warmth contributes to the planet's balance. You are both fleeting and eternal. As the sunlight fills the room, you realize that the line between sleep and wakefulness is much like the boundary between systems in space, a gradient, not a wall. You do not cross it suddenly. You drift across it, like a comet gliding from darkness into light. Your mind, still calm from the night's journey, carries with it the stillness of space and the wonder of distance. There is no rush to return. Morning is not a command. It is an invitation. You think of all that continues while you rest. Stars fuse hydrogen into helium, galaxies collide, cosmic rays race across interstellar distances. In the vastness of it all, life persists on this fragile planet, growing, changing, learning. The universe is not indifferent. It simply follows its nature. Yet within it, consciousness has arisen, capable of wonder, capable of tenderness. You are part of that rare awareness, able to see the cosmos and know that you are seeing it. Outside, a bird begins to sing, a small, rhythmic sound that feels like the continuation of everything you've been contemplating. The universe expresses itself through light, through gravity, through song. Each is a form of vibration, of energy translated into meaning. You realize that even this morning, simple and quiet, is another version of the cosmic dance, matter awakening to its own beauty. You rise slowly, not to leave the night behind but to carry it with you. The calm you found among the stars remains. The sense of belonging endures. You step into the new light with a kind of reverence, knowing that every photon that touches you has crossed unimaginable distances. The sun, in its generosity, offers you the warmth that once ignited planets, sustained oceans, and will someday fade, but not yet. For now, there is life, and there is morning. As you breathe in, you feel both ancient and new. You are a continuation of the same processes that built the visitor, that built the stars, that will build what comes next. In every heartbeat, there is creation. In every breath, an echo of the Big Bang. The cosmos does not end at the edge of the atmosphere. It continues in you. You stand there, in quiet gratitude, as the day begins. The interstellar traveler is gone, but its meaning remains, that we are part of something immense, something ongoing, something beautiful. Science gives you the facts. Reflection gives you their rhythm. Together, they create wonder. You close your eyes for a moment, feeling the sunlight on your face. The warmth is steady, gentle, unhurried. The same warmth that touches comets, planets, and drifting dust now touches you. Everything is connected by that one stream of light. And so, as the universe continues its silent work, stars forming, galaxies drifting, comets wandering, you awaken into its gentle promise, that no matter how far things travel, they all remain part of the same story. You open your eyes to morning. And for a moment, before the day begins, you smile, knowing that the cosmos, in its endless motion, has carried you softly from darkness into light.